that's this this one you can see up on the screen now. We had 4 machines in total that were fitted with 8-metre weeders on the back of them. So what I'd do, I'd load the robots up and take them contracting around here at Emerald in central Queensland, and go around to different farmers and growers to not only sort of showcase the technology but test it out as well. So when I started taking these machines around, the general thought that the Weed It was a great tidy up tool. So it's just a green on brown spot sprayer. Our customers would call up and say, "Hey, I've got this paddock that's got a heap of feather top in it that's too far gone, and there's no point in me trying to spray it. Can you come and fix it for me?" So the impression we got from people was that the Weed It was seen to be a silver bullet in fallow weed management. So here you can see a couple of paddocks that we were tasked with trying to tidy up. On the left there, you can see some lighter red soils, sort of riddled with feathertop Rhodes grass, and on the right is some sorghum regrowth. So most of it's sort of dying or dead, but there's still quite a bit there. Both of these sites that we sort of thought we'll give a bit of a trial, about 70 hectares in total. And we were sort of looking at the best way to try and control it and get it back to a stage where we were, where we'd be happy with it. The cheapest option, the best option we sort of looked at and thought of was, cold steel, get the plough in and work the country, but something we were keen to avoid in a zero-till farming system. So here's those same patches of dirt a couple of months later. We're able to avoid ploughing those areas and control all of the growth with the robots, with those robots we saw before, fitted with a Weed It on them. So it took about 4 or 5 sprays, spraying every 2 weeks, particularly to get on top of the feather top on the left-hand side there. The high density of the greenery in the area meant there wasn't a significant saving in chemical, if any. We probably even used more because we were using a higher rate, going slower with the spot sprayer. Probably would have been a fair bit cheaper to go and plough it, but what we were able to show though is that, and what we learnt was using the Weed It on a regular basis might present some opportunities that we hadn't sort of previously seen for fallow weed control. So yeah, what we learnt was that maybe the Weed It wasn't a silver bullet that we'd hoped for, or that some had hoped for, but it certainly was something that we could use on a regular basis. And sort of change the way we control weeds in a fallow situation. So since those early days of the SwarmBot 3, the robots have grown a bit. Now we're generally running, we've delivered 14 machines out there to customers now, but generally running in broadacre situations with 12-metre booms on 3-metre centres. So that's fitting in with current controlled traffic farming systems. One example of someone that's been using a robot is Elton Peterson. He's had Oscar here that you can see for 2 fallow seasons now, and is starting to see some pretty major benefits of the Weed It being used on a regular basis. So Elton farms near Mooney, just on the western side of the Darling Downs, where it predominantly grows winter crops of wheat and chickpea. So since November last year, he's sprayed his whole farm of about 2,000 hectares or 2,200 hectares about 5 times, and has spent $4.50 a hectare on chemical, which is a pretty significant reduction in chemical usage. So I guess what does that actually mean? I guess that's the exciting part. So not only has he saved a fair bit on the chemical bill, admittedly, a lot of that savings going to the technology that he's investing in, but he's seeing a shift in the dial on spray decisions and the agronomic changes and benefits that they've come a bit sooner and have been a bit greater than he sort of originally thought we were going to see. So before Oscar, the country that he has had a strict no-till farming system in place for about 20 years. So he took over the farm about 5 years ago. Due to the resistance in the feathertop roads and barnyard grass, the system was getting to a stage where it just wasn't viable to go out and blanket spray anymore, because there were just such large patches of these resistant grasses that were just getting far too hard to control. So this left him with a couple of options, and that was, cold steel, getting in there with a plough, or spot sprayer. So started off with just working the country a few times to get on top of the on top of it, but now is going in and controlling it with a spot sprayer. So now, instead of waiting for the weeds to be big enough and having enough numbers of them to justify going out to spray, Oscar's over the country on a regular basis, about every 3 to 4 weeks, depending on the moisture situation, and getting on top of his weeds while they're easy and smaller and easier to kill. So I was actually talking to him yesterday. He hasn't been able to spray for the last 6 weeks. He's had about 200 mils of rain, sort of in the recent falls. But he's about to start spraying again. But I guess the impressive thing is that there's not much weed pressure to talk of. He said there's very few grasses germinating, and the main things that he's seeing are a bit of milk thistle and suspania popping up. So I guess in summary, of the spot spray, of the green on brown spot sprayer, there's some pretty big benefits in reduction of use in chemical. So not only reduce number of weeds, also reducing that seed bank. So getting on top of the weeds before they set seed for the next generation. Getting the weeds when they're smaller. And this is something we never really thought about. If you're able to go over and spray a weed when it's activating only 1 nozzle instead of 2, all of a sudden you're halving your rate of chemical use. So that's a pretty significant saving there. But also the ability to change and rotate chemistries through regular application. So you obviously reduce the resistance burden. Also mentioned before about changing the agronomic, I guess, decision about when do I spray. Generally, I suppose it's been limited to how many hours a man can do in a day, but by putting it on a robot and the way it's set up, the only cost to him is fuel. So burning a bit of fuel to get over the country, obviously reducing the chemical, so that doesn't cost much at all. And in the future, what can we expect to see? Well, I guess that's the sky's the limit a bit, but with this technology, it's probably reduced reliance on residual chemicals. So if we're able to go and get on top of our weeds over a number of seasons, there might be a reduced reliance in need to use chemicals, open up cropping rotations, and give us the ability to open up the potential for different crops. And through the spot or the spot specific allocation of or applied application of something, maybe it's a reduced reliance on chemicals altogether. So maybe we can move from a spot sprayer itself to a weed chipper, which no doubt you would have seen about. So that's probably enough about green on brown spot spraying. After all, we're here to talk about weed ID and green on green spot spraying. But I thought it was important to touch on that topic of green on brown and what we've learnt to see the change in the way we think about weed control, particularly in the fallow situation. So we've gone from a somewhat reactive situation or response where we're spraying when required to very much a proactive approach to getting on top of the weeds. So now that we've finally got to the topic, what does it mean from here, and where do we see it going? No doubt there's plenty of comments and questions I'll ask that you're talking about at the moment, and I sort of saw a few of the topics come up in that last presentation from Caleb. But so our previous work in the spot spraying and fallow, there's some pretty practical learnings that are certainly important to remember when thinking about weed ID and green on green spot spraying. First one is that it's probably no silver bullet. I think the unfortunate truth in ag is there are no silver bullets, but certainly another tool in the toolbox for when we're controlling weeds and how we approach that control on weed, particularly in crop. So when we're talking to a lot of prospective customers around there, a lot of people are saying that they're probably going to hold off getting to a robot until we can put a green on green spot spray behind it, because that's what's going to hit the nail on the head and really deliver the value. I'm sure it's a hot topic, and it was mentioned there before, but just the sheer number of crops and different weed situations that need to be accounted for is pretty massive. But after seeing, reducing the time it takes to actually learn about different weeds and the grass weeds and ginger, it's pretty exciting to see. So the next question I suppose we look at that we see from a robotics perspective is how many of the weeds are actually going to be seen when going through a crop. So no doubt that's going to vary with the crop depending on canopy and the coverage and what can actually be seen. But say the technology gets into the paddock and it does see, I guess, for example, 30% of what we're looking for, 30% of those weeds, what do we do about it then? And if it sees this many on the first pass, how many passes per season do we have to get to actually benefit from using this sort of technology? And maybe the number's higher, that maybe it's 50, 70, 90%. I guess it just depends on the different situation and what's happening out there. So there's certainly some good opportunity here to increase the number of passes in the paddock per growing season, and that's something we've particularly seen with robots, is you're able to be out in the paddock more often and you're able to make those decisions more regularly about what actually needs to be done. So I guess, the next couple of presentations from, we'll find out a bit more about exactly where the technology's up to. So I guess the next interesting question is what actually happens when the weed's spotted in the paddock? So currently my thoughts are that it's just obviously a selective herbicide or can be a selective herbicide, particularly in something like wheat, that doesn't damage the crop around it too much. This will also open opportunities for use of higher rates of those selective herbicides. And obviously there's all of the benefits that come with that regarding resistance. For example, MCPA in wheat. Right now, I'm not going to go out and apply the highest rate possible, but because it's going to have an effect on the overall yield of the crop. But if we can reduce it to 10%, all of a sudden we're using these chemicals at higher rates in site-specific areas. We're going to get that application side affected more, and there's, I guess it's getting on top of those weeds while they're still easy to kill and easier to control. And as sort of mentioned before, we see a very high value add when the technology is at a stage where you're able to use a knockdown in different crops. So those grasses in ginger. So by moving from a selective knockdown to a knockdown, this opens up plenty of opportunities, I suppose, particularly in terms of chemistry. And something like this may not be possible on conventional farming equipment. And it's something we see a massive opportunity for robotics and robots that are moving slower through the paddock with greater stability and accuracy. So we saw there before the CNC machine, or the couple axis machine, that was able to apply very site specific and accurate chemical application. So what's next from here? I guess we've moved from spot spraying for fallow management, and now we're looking at spot spraying for in-crop weed control. But what if we could get away from the spraying altogether? I suppose that's an exciting part. But I guess this will open up opportunities for organics and different industries that maybe I haven't been exposed to, I suppose. But there's certainly plenty of talk of what's coming next and what's coming to fruition, with people working on different things all over the country. So whether it's microwaves, weed chipping, zapping weeds, what if we could even get a biodegradable cryovacuum machine on the back of a robot to go out and actually bag weeds that have set seeds, so then they can stay out there and the UV can break down the seeds in the bag. I guess I'm probably shooting off on a bit of a tangent there, but it brings me to my next point of the delivery of the Weed ID technology. And that's probably expectation management and user education. So a key moving forward, I think, is ensuring that the early adopters and the customers have realistic expectations about what can be achieved with the technology, and no doubt that's happening right now with the commercial products that are out there. And how effectively it's going to be working. So once it is out there and working, no doubt these early adopters and these customers are going to be pushing it to be as successful as the technology can be. I guess considering all of this and everything you're coming across in the last, or yesterday and today as well, there's massive opportunity for this sort of technology to be another tool in the toolbox for combating weed issues both in Australia and around the world. As we saw with the fallow spot sprayer fitted to a robot, it took plenty of hours in the paddock and mistakes and learnings along the way to get to the stage where we're at now with delivering that high value for the single application. And it's so much more than just a chemical saving. It's a new perspective on weed management, as well as farming systems in general. And I think that's the most exciting part about this technology. What can we do next, and where are the benefits in a practical setting that we just haven't realised? So no doubt there's things that we haven't got this into the paddock yet and we may not have thought of, or maybe I'm just a bit naive and everyone's already well ahead on that. Lastly, you'll see up here, this is an image of one of our latest swarm bots hooked up to an 18 metre gold acres tow behind that's kitted out with some technology that we've been talking about here today, and that's a Bilberry system. So this is something we're working very closely with Bilberry Gold Acres and our customers to get into the paddock and really push the boundaries of what it can actually do. It's certainly very exciting to be part of this next step. And that's me done. I suppose that was just a bit of a perspective from SwarmFarm and or myself in particular about robots and where we see the future with green on green technology.
Thank you, Tom. I guess probably the easiest way and quickest way is for people to come up to the computer if they have a question, or
there's two on chat.
There's two on chat.
Got time for one quick question, Tom? Can you hear me?
Yeah, I'll go to that.
You want to do the chat?
There are no chats.
Oh, okay.
They were technical issues.
Any questions for Tom? Stunned audience here, Tom. Mine's
very good.
Yeah.
Actually, I was just wondering what Sorry, Tom. Thanks for the presentation. This is Eric. I was just wondering if you could. Are you able to tell me what sensor system that you're using there? Is it a camera or just like a UV, or it's how you measuring the where to spot spray?
Sorry, the weighted spot spray. So that's just an infrared system for the fallow, you mean?
Yeah. Okay. That answers my question.
Yeah. So it's just an infrared off the shelf weighted setup. So for
and how many nozzles does each system?
Yeah, so on a 12 metre, they're currently going out with 4 nozzles per metre.
Okay.
So one camera per metre as well.
All right.
Each camera has 1 or 4 channels in it, correlating to each of those nozzles.
Okay. And does your system sort of tabulate the data? Does it keep a record of spray points, I suppose, and GPS coordinates?
Yes, yeah, we do. Yeah, so we get all the nozzle activity out of the weed. So the weed, it's an off-the-shelf product. We make the robot itself, and then the weed, it's an off-the-shelf product which has been
I see. Okay.
Out for about the first one came out about 20 years ago. But yeah, we use that information and then present that as well to the users.
Okay. All right. Good. Thanks.
All right. That was really good. Thanks, Tom. Appreciate your time and effort. So well done.
No worries. Hope you got something out of it.
Thank you, Tom. Guillaume, would you?
Yep. So no, I'm glad to be presenting today, especially after Tom. I think that's a very good transition. So I listened carefully to the presentations yesterday. And so I decided to just change a bit mine. So I made it a bit more technical than usual, given the audience and the presentations I saw yesterday. So I hope it will be interesting for you to see that. And I hope it makes sense as I just did it yesterday pretty quickly. So I'm going to talk about green on green spot spraying. For those of you that have not seen yet what it is, here is a video that explains pretty well what we do. So it's cameras that are installed on usually sprayer booms, one camera every 3 meters. They look in front, and in real time they make the difference between the weeds and the crops, and then turn on individual nozzles. Here it is spot spraying radish in a wheat crop. So that's basically green on green spot spraying in action, and that's what we are doing. So on the tech side, here is our stack basically. So we have different main components. The first one is obviously hardware. So on the hardware side, we've got, as I said, one camera every 3 meters. On the boom, these are RGB cameras looking in front so that we can work at high speed. Today, normal speed would be 20 kilometers per hour for us to work at. For each camera, then we've got one computer, so basically embedded computer, so that we can run AI algorithms. And then we've got a switch basically to transfer data and power, or several switches, and then just an operator touchscreen in the cab. For the hardware side, we are integrator. We do not want to develop any hardware. That's very difficult, very costly, and there are already great options on the market. So we basically take the different parts and then put them together, integrate them, and make sure they work well, and they are, adapted to agricultural conditions. Then the second piece of the stack is embedded software. So we need the software to just so that the cameras can talk with the computers, that the system as a whole can talk with the sprayer, with the nozzles, with GPS, with everything. So that's a big part. We do everything internally. Then another big part obviously is artificial intelligence. I'll develop a bit more on that later. We develop these algorithms internally. There are lots of things that we do. I haven't put it there, but we also have a team focusing on cloud products. That's interesting because, for instance, we've got our own labeling platform to manage the data. So a lot of the images that we get back from the field. And then we've got a whole annotation pipeline with, labelers that can connect on our own platform, and then, work on the masks or the bounding boxes so that it can feed our labeled database. We've got quite a strong view on patenting. We have filed 8 families of patents in lots of countries, and yeah, we have anteriority on our patents on all competition, even Blue River Technology and John Deere. So yeah, we've been that for a long time. Just before I explain a bit more about the tech, I just want to get back to the basics of why spot spraying. I think Tom touched very well on that before, especially on fallow situation. But when you speak about green on green, it also has lots of advantages. So the first one would be resistance management. When you spray just on the weeds, you spray a lot less. So usually what we see is probably 90% chemical savings. So you spray actually 10 times less. So the interesting part is that you can actually use different chemicals that would be too expensive to use broad blanket, or you can just up the rate, or you can spray at different times. So it opens lots of doors regarding resistance management, working with green on green spot sprayer. The second one is weed seed bank management. So same as for fallow, it's really helpful, to be able to know the weed infestation over the year, be able to have the right product with the right rate to be able to control the weeds and prevent them from setting seeds. The weed mapping, I think, will be especially useful over the years, because you'll be able to see the quality of the work that you do year on year, and if you are actually reducing the pressure or increasing it, and then you can decide to change the way you work. Obviously, cost savings is a big one. You spray less, you spend less. So yes, by spraying 10 times less, maybe you have to come an additional time when you do camera spraying. I'll get back also on that later. But even with that, you still make significant savings. You spray less on the crop, so obviously you reduce crop damage. We do not know yet the impact on the yield. We will work on that this year. But if you just spray on 10% of the paddock, it means that 90% of the crop will not have to process the herbicide, and so we'll just keep growing more naturally and without being kind of aggressed by the chemicals. So I think that's positive for crop development. And then in general, it's very good for sustainable development. So obviously for the planet, but also for the health of growers, being less exposed to chemicals, being able to just use the chemicals at the right time, which means that it can help also prolong their lifespan and avoid resistance to arise too quickly. So lots of different benefits for spot spraying. And so last year we've been working extensively with some growers in the north of the Western Australian wheat belt near Jourdain. We've spot sprayed on about 12,000 hectares. We've spot sprayed wild radish that you've seen in the first video in a wheat crop. So we've done it with different chemical product, different nozzle setup. The conclusions were that we usually hit about 90% of the weeds in a real life scenario. So we actually had a third-party agronomist, Peter Norris, that throughout the season made small plots in the paddock, and then just came 14 days after treatment, 28 days after treatment to compare the result with the situation that was there initially. So we had very good data. And so that's why we know how many weeds we hit, so about 90%, and how many we killed, which is usually about 80%. It's a lot linked to the amount of chemical that was applied on the weeds. So when the cameras see a weed, they usually just open one nozzle, as they are quite precise. It was a 25 centimeter spacing nozzle, boom. And so we didn't have this overlap between several nozzles. So sometimes the rate of the chemical was just a bit low, and some weeds were hit but not killed. So that was a good learning, and that's something that we've changed for this year. And obviously the savings are pretty big, as you can see on the table. So now I'll just touch base quickly on some of the tech aspects that were mentioned yesterday, especially during Asher's presentation. So first, so I'm going to talk a bit more about artificial intelligence and some of the learnings that we had. I hope it all makes sense. So first, you defined yesterday, Asher, recall and precision. So in very simple terms, that's how we define them. Recall is basically our hit rate, how many weeds we hit, how many we miss. So we try to have this recall as close to 100% as possible. And then the precision, it's our metric to define the overspray. So it's the false positives. And so if the precision is not good enough, then we will just spray chemical when it's not needed. And so it's going to be less savings for the growers. So that's how we define these two key metrics for us. And so the first thing was to understand, what is the need from the grower. And really the starting point is it's good to save chemicals, but the number one priority of growers is to kill the weeds and to work on this resistance. So that's number one priority. And for us, it means that recall is far more important than precision. So I understand that it's completely linked to the method of treatment. Obviously, if you use different method, that might not be exactly the case, because we use selective herbicide normally, so we do not kill the crop. So that's also one of the reasons why precision is not too important for us. So maybe that can be a bit different in some situations. For instance, we will be looking at some new applications this year, like spraying blue lupin in lupin. And one option to kill this blue lupin is to actually spray glyphosate or a non-selective herbicide. And then precision might become a bit more important, as they don't want to kill too much crop, even if quite a few growers told us that they would be willing to kill the crop in some situations, because the weeds just get too problematic and too resistant. So for instance, in some very hard ryegrass situations. So maybe share some learnings that we had along the way. I've just highlighted 3 over the next 2 slides. And I think you also touched base on most of them yesterday, but we really felt it was completely true. So the first one is that paddock metrics are really different from computer metrics. So we talk about recall and precision. So we follow them. We follow them just out of our artificial intelligence pipeline. That's a good trend. But then we also follow them in the paddock. And that's quite interesting to see that the correlation between paddock metrics and computer metrics is not perfect, and actually not perfect at all. There are lots of factors that influence it. Just giving a few examples. Sorry, one of the very important one is shading, meaning that sometimes when the cameras look at the paddock, they look in front, the crop will just hide the weed because of the angle of view. And so on a picture, you will actually not see any weed. So you can get to 100% recall. You're very happy, but actually in real life, you will miss some weeds. So that's something that, explain part of the difference. But also in another situation, actually there are weeds that might be very difficult to see that are actually next to some pretty big ones. That happens in patchy situations, and radish is quite a patchy weed. So actually this can be a benefit. So sometimes the metrics can also be better in the paddock, better than in the computer. Another very important one is bad data means bad algorithm. You discussed, yesterday how to annotate images, how to make sure it's good, and I think it's a key point. You have to make sure that you've got quality data. So it starts from a good image from the beginning, then attach the right metadata. So it can be, there are lots of, there is a lot of different data on your Weed AI platform. But, time of the day, the wind, the weather, there are lots of things that are interesting also to attach. And then finally, I think probably one of the most important one is annotation. So be it bounding box or masks or whatever, it should be precise and it should be good. Otherwise, it just creates a lot of confusion for the algorithm, and it will just learn nothing or learn in a bad way. So it's very important to build quality improvement processes. We've built a lot of review in our pipeline. So we've got people that are dedicated to review the first labeling. Then we even have a third review in some cases. So reviewing and making sure the data is of good quality is just absolutely key. Another point that's very important is just spray as many times as possible. Since you save money with the cameras, it is then possible to just go an additional time. I think it's something that's also made possible thanks to technologies like the SwarmBot, and it's going to be very, very beneficial in the long term, because basically today you just spray once blanket spray. So first, you do not kill all the weeds. There are still either resistance or some weeds that are shaded from the chemical. So what happens when you go to camera spraying? You will actually miss a few more weeds. So the job will not be as good if you just go once, just because of this shading thing that I mentioned, and just the cameras that do not detect 100% of the weeds. But actually, if you go another time, you will very likely hit the weeds that you've missed before, but also new weeds will have germinated in the meantime. And these new weeds, you wouldn't have killed them with the first blanket spray. So it's actually a way to really control the different growth events of the weeds. So if that's possible, spray more often is a very big benefit. Now, just a couple of points on what's coming next.
Yeah, 1 minute, please, Guillaume.
Yep.
Sorry, I meant 1 minute to go.
Oh, sorry, 1 minute to go. I thought, yeah, that's all good. Yep, no, that's the end. So I just touching base on what's coming next. So today is basically, you can say, dead radish. So that's a big focus. So these are all images from the cameras. Tomorrow, big focus is actually to have more dead radish. So that's a big focus on us to improve that. But also targeting blue lupin and lupin is a big one. So it's, I think, a very good application, especially in WA. We also work this year for grass in cereals, grass resin cereal, and grass resin canola. These are big ones. And then obviously, I think Tom showed the same picture, but that's very exciting, working on automation. It will bring a lot. So I'm all done. Thanks for listening, and I'm happy to take any questions.
Thanks, Guillaume. Yeah, we've got time for a quick question.
Just from an in-crop herbicide use point of view, have you made any inquiries around registration, labelling, and whether the optical spot spraying is going to require different registration to a conventional boom spray from a crop safety and residue point of view?
So for now, there are no changes. So the same labels. So for now, the same labels apply to spot spraying. I think it's going to be an interesting point to work on. Quite a few AgChem companies are discussing with us and are interested in working on different labels, and so working with the APVMA on that. But for now, there's nothing different.
Do you want to read out
Yeah, we do have a question on chat from Arnold as well. He asks, with reference to the Weed AI database, can you expand on the 45-degree camera angles that you've chosen instead of the 90-degree used by Weed AI?
Yeah, so one of the key things about that is speed. We want to be able to work at a high speed. If we just look straight down, then either the camera has to be really in front of the boom, or it's too difficult. So you need time to process the image, and also you need the image not to be blurry. And so if you look straight down, if you don't want the image to be blurry, you need very expensive cameras. So this is, I think these are the two main reasons why we chose this angle looking in front.
I've got one quick question for you, Guillaume. Have you looked at the Weed AI database, and will you be able to use it?
That's a bit linked to the question from Arnold that just came. For now, it's not the right angle, so I think it's a bit difficult for us. We've seen it. I've shared it internally. So for now, it's not really plug and play for us. So we'll see also how it goes and how it expands. As I saw yesterday, that you have lots of plans on making it a community and having more images.
Just to expand on that a little bit more, currently the images on there are at 90 degrees straight down. That's the ones that have been uploaded to it. You can't upload other angles. We support any. That's one of the things that you can have any angle you want. Now, so if you have images and you want to upload them, we would take them.
All right. With that,
as well.
thank you, Guillaume. Appreciate it.
First of all, I'd just like to thank Michael and Guy and the team there at University of Sydney for organising this event. I'm sorry I can't be there in person. I was there last year, and it's really a thrill to see what the WeedEye database has become after those discussions we had last year. That again, a great lineup of speakers here. Seeing Tom from SwarmFarm, Guillaume from Bilberry, and the relation to what you guys are doing with that WeedEye dataset. We're looking forward to be able to use that WeedEye AI dataset to test our algorithms in fields that we haven't been in, because you guys have collected those images for us. And I hope to see the open source community sort of contribute to that. So I think it's a really valuable thing. So what I've been invited to do today is kind of provide an industry update of AutoWeed, a green on green spot spraying, site-specific spot spraying for Australian agriculture. So I'll give you a bit of a brief history of us and the developments we've had over the last sort of year. It's been an exciting year despite the challenges we've had. I was actually supposed to be in Gundawindi last week to do a demo. Unfortunately, both flood and plague prevented me from being there, it seems. So it's just it's that time, unfortunately. But it's really great to have this type of interactive session to link with all of you. So AutoWeed was spun out of James Cook University postgraduate research dating all the way back to 2014, where we have publications all the way back to there. It was back in the crude days where we were, really bumbling around with a camera and a processor and sprayers. It's really cool to see where the technology has come since then. We've learned a lot along the way, and you guys have as well too, which is cool to see. So we're now operating in the heart of Townsville, the business district on Ingham Road. We set up an office space last year, and we have 2 full-time and some 3 part-time engineers who are basically putting our systems together and getting them to Australian growers as best we can. We build machine vision and learning systems for Australian growers. That's what we do. And right now it's really exciting because by June, we're going to have 32 individual detection units actually operating in the field that we're learning from, because as this technology is brand new, we're still learning, as you've seen in some of the other presentations, about how they can be best effective and tailored to given applications. So our core technology is to develop, manufacture, and service our proprietary detection units entirely in-house at Townsville. So we work with growers to also retrofit these to existing booms to hopefully reduce the cost as compared to a large fit-for-purpose 36-meter sprayer by John Deere or something like that, which is kind of costed out a lot of growers around Australia. So, and we leverage our in-house capabilities as engineers to develop our own software and hardware, which enables us to really get the best out of our units for each given application. We customize our AI and our hardware to each given situation. And we have really focused in pasture. Pasture is kind of our bread and butter. That's where our industry, our work brought out of, based in Townsville in North Queensland, where we have a lot of cattle growers. And we're also moving into sugarcane, where we feel it's been a little bit forgotten, and there's some interesting challenges in there that we're tackling. So there's a shot look at the per meter sort of system that we would offer with our core detection unit, and it can be used for anything. So mechanical control, spot spraying, and that's another important industry development that I'm very keen to have an eye on, what the guys at University of Sydney are pushing forward for mechanical means of control or laser control and things of that nature, because detection will need to be the key for that as well. But yeah, site-specific spot spraying, it's existed for almost 25 to 30 years. It's a concept that a lot of people have arrived at, and it reduces herbicide for the grower, and it opens up a lot of interesting innovations as a tool in the toolbox for smart weed management and integrated weed management. So the AI is the detection, is the key to unlocking this tool, and it's ready. And it just needs to be fine-tuned to each given application. Oh, skipped over one. So I thought I'd just share some video of a couple of the systems that we've developed. So what you see here is a 3-meter system that we developed for a SmartFarm Small grant, working with Warrakirri Cropping in Gundawindi, Willaroo Farm, as well as Northwest Local Land Services. We delivered our detection unit. There's 4 detection units driving 3 nozzles each with 25-centimeter nozzle spacings. This is the first green-on-green solution for Harrisia cactus in pasture. Now, at the time, it looks a bit drought heavy in that region, so I wouldn't technically call that green on green. If you're really looking at the color, it's probably green and purple on a brown yellow background, but nevertheless, it shows that the AI detection can do machine vision based detection that can be applied in green on green and green on brown situations. And here's a closer look at the system. So 4 units entirely developed in-house. We worked with Sprayer Barn in Moree to deliver a custom fitted boom with an adjustable winch for the height adjustment, and it's all fitted to a John Deere Gator UTV with a very simple control box allowing control of each individual unit for the driver. And it's now being used at Warrakirri Cropping's Willaroo Farm to treat cactus. Previously, the management for cactus is hand spraying. You need to put about 1,000 liters per hectare on the cactus. You're really soaking it to get a kill. And so we've used very high rate nozzles to be able to deliver this much water rate. And yeah, while we're at Warrakirri's Willaroo Farm, we also tested the vehicle out collecting some data in a wheat crop targeting sow thistle. And we had very strong results. So that's 88% detection accuracy, or that's recall in the paddock. And that's on data set. In the paddock, we saw an improvement in knockdown above that 88%. So usually when you go to the paddock, the number of control for knockdown is higher than the, for our system, than the detection accuracy, because the frame rate of the system allows you to have multiple looks at a target. And if you're operating at 88% detection accuracy and you get 5 looks at a target, your hit rate could go up as soon as you hit it. So that was an interesting result. Here's some details on the system. We used flood jet nozzles to really douse the cactus, and we can operate up to 10 kilometers per hour. We used the research permit to put on Grazon Extra and Metsulfuron, and that was funded by the grant, which is really great. So we've loaded up Willaroo Farm's Grazon supply to battle cactus, which really, it's a tough weed to control, and it's really taken over a lot of the sort of southern Queensland, northern New South Wales, and it's even stretching further south. Our first system that we delivered to was targeting Navua sedge in pasture, and it's a bloody tough weed to detect. So the really key feature that stands out about this weed is its slight color change and its structural when it stands up, its structure compared to the grass in the background. Pasture presents challenges with varied plant life in the background that makes it non-homogeneous, unlike a crop where the background can be more tailored and trained. There's a lot more variability in our data sets. And so we've had to tailor different AI detection algorithms for pasture than one would use for crop. Another interesting thing is those metrics for precision and recall change depending on what application you're in. For pasture, we're a little bit more happy for having overspray because you want to get 100% weed knockdown. Especially in this case, we're targeting Navua sedge, which we use a selective herbicide, Sempra, to control. So in some crop situations, the precision required is much tighter, and the recall is always high, obviously. So this is really cool. We use twin jet sprayers from T-Jet to target in both directions. We operated about 5 to 6 kilometers an hour here, quite low speed because we're in undulating lands. And this system is a bit older. You can see where the cameras are significantly higher above the sprayers. We've now gotten the cameras down onto the same level for our standard offering. And we're achieving high rates of detection accuracy in the field, in pasture, which is really good results. And this has been in use on a Malanda farm for about the last 2 wet seasons. So we're getting some really good data on how this stuff works in pasture. And we're looking to sort of wrap this up into something that we can service multiple pasture growers across the North Queensland area. It's a 4-meter system. Each camera controls 2 sprayers, 50 centimeter spacings. We can custom design our solution for whichever agricultural application we have, including the nozzle spacings, the camera, and the hardware on the AI side and the software on the AI side. So we find that you have to have an integrated approach to be able to target specific algorithms and hardware to different situations. And yeah, we used on-label Sempra and Banjo to control sedge. Right now, actually yesterday, I had right before Easter, we had to squeeze in a meeting with an installation of our latest system. So we received a Great Barrier Reef Foundation grant to innovate and develop a 24-meter spot sprayer for sugarcane. And we're aiming to reduce knockdown herbicide usage by at least 80% in some key Burdekin catchment areas that flow to the Great Barrier Reef. And we're working with Sugar Research Australia, who are helping us to trial the technology. They've got a lot of experience dating back to usage of weed seekers and weed its in the early 2000s on cane, because the fallow interrow, cane paddocks are 1.6 meters wide, and there's a pretty large interrow there where some people have trialed green on brown solutions. So there's a nice sort of a bedrock of some learnings that we're able to stand on the shoulders of in order to get a system that is working in cane. And the cane growers are really excited to have something that's going to, you know, reduce their burden on two sides, because they're being hit by regulators pretty hard, and they also want to, you know, reduce the cost of their herbicide usage. So we're kind of a win-win right there for sugarcane growers in the north. The system we're developing and we're currently installing is a 15 unit system, 13 units on the vehicle. We have 2 spares there. The way we've designed our units is that they're modular. If you have a failure, you can just swap it in and out. So it's 13 rows, 1.6 meter row spacings on a high-rise sugarcane sprayer. We're basically going to target some priority grass and broadleaf weeds, and there's a hell of a lot of them in cane. So our work is cut out for us. Guinea grass being the priority. It's similar to wild oats and wheat. So as an organization, as a startup company, we're really excited to finally have a 20+ meter system and target some broadacre weeds that are a bit more different to our challenges that we faced in pasture. And yeah, we aim to reduce herbicide reduction, get weed knockdown, and also show a reduction in the concentration of herbicides in runoff that flow to the reef, which is mapped to a reduction in herbicide usage. So a little bit of high level sort of information about how our algorithms work. You guys have shared a bit more in your technical details. I haven't had a time to sort of add in technical stuff here. So this is kind of a quick look at how we do what we do. We use machine vision and deep learning to detect weeds. We have a varied palette of the deep learning algorithms that we utilize, from classification, object detection, segmentation. Each one is a tool that we can use, and each one is better used in different applications. And we've got a nice spectrum of applications that we're working with. No matter what, it requires thousands of labeled images with accurate labels. That was a great point that Guillaume mentioned. You need a robust labeling regimen to be able to achieve any level of terminal accuracy of your detection models. The most important step is dataset collection and dataset annotation. And it's really cool to see Weed AI also put their flag in the ground that is an important part that the industry needs for this. So right now we have over 1 million images in our data set across 15 different weeds, and we're building on them as we speak. And we tailor our custom and AI and hardware solutions for each application. So how does it learn? Every system that we install will have an internet connection to our head office in Townsville. That allows us to get that regimented process of data set collection back to our head office, labeling and reviewing, make sure that our labels are correct before we feed them back into the model for updates. And the internet connection to the farm allows us to easily update the detection models, update our software, and keep the site-specific spot sprayer up to date, because that's the key. The interesting things we're learning is how a data set variability will map, whether it's within paddock, within farm, within region. The more data we get, the more tools we have out in the field, we're learning really cool things about how this technology needs to be rolled out. And yeah, that's one part of it. And how effective is AutoWeed? I've just sampled some of the trialing that we've done on those 2 videos and 3 videos that we showed. So for our Navua sedge trials, we've now had, this is on 1 wet season averages. We're also in the midst of 1 other wet season. It's been difficult to get our current vehicle in because it's so wet up here this season. But what we see is basically very good herbicide reduction in Navua sedge in pasture. We go from $100 a hectare for Sempra, which is very high, down to $10 a hectare. We're basically on the farm we're working with. He's done a pretty good job. It's not out of control. He's got about a 10% infestation rate. And obviously these numbers of herbicide reduction will change depending on the weed spectrum in the paddocks. Different story for Huracea cactus in pasture. You don't see the same reduction in herbicide. What you do see, though, is a reduction in the labor required, because compared to the normal method of control, traditional hand spraying, the AutoWeed spot sprayer saves about half the time. So you're seeing a slight reduction in herbicide usage, but we needed to up the rate to be able to ensure kill. So really you're seeing a reduction in labor and herbicide there. We also did a quick trial on milk thistle and wheat at Warrakirri. And we showed roughly that we could reduce the herbicide on a small trial, dependent on the weed density, by a significant percentage, up to 75%. But obviously that's dependent on the weed infestation level. And the photos you see down here are just some of the plots we did for our Harissa cactus spot spraying, where we compared traditional spraying versus spot spraying. And one other note is how fast is our algorithm. So that's been one limitation of these, is the the trade-off between speed and accuracy. Current AutoWeed systems operate at 15 kilometers an hour at a maximum, but that can be tweaked depending on the hardware utilized. We customize our software and hardware to suit the given application. That allows us to choose what speed is the determined one to operate at. In pasture, we typically operate from 5 to 10 kilometers per hour. The navigation through these lands is a lot more difficult. There's a lot more random stuff in the way in undulated lands. While in broadacre cane, we can get up to 10 to 15K an hour while achieving the same required level of precision and recall. So that's kind of it for a snapshot. I thought I'd just summarize where we are with things. So yeah, we're operating now out of Townsville with our head office, and the really summary for us is we're aiming to deliver retrofitted systems across Australia in pasture, crop, and even horticulture. We're starting to look at some solutions there. And our AutoWeed network is being built to support our systems with model updates so that our site-specific performance can stay up to date. So as new data is found by the vehicle, we can actually improve our models to adapt to it. And there's a lot of innovative work with how AI can be used to find and learn unseen weeds. And so we're really excited to be partnering with some research institutions as well to get the latest and greatest advances in the AI side. But the important stuff for us, we feel, is retrofitted detection units, reducing the cost for growers, regimented data set collection. So we've sort of built in our pipeline that data set collection is the most important thing, and the efficiency of annotation. If we can get the annotated images out quicker, we can collect more data, we can learn better. And tailoring AI and hardware to the given application really does unlock those trade-offs between speed and accuracy. So that's it for AutoWeed. I'd just like to thank you for having me come here, meet via Zoom and share my 2 cents, and happy to answer any questions. Thanks very much.
Yeah, good on you, Alex. Thank you for that. That was great. Good to see how you've progressed in the last 12 months.
Cheers, Michael.
We've got time for a quick question.
Yep.
Asher?
Hey, Alex.
Hey, Asher. How's it going?
I was compelled by the idea of tailoring your AI to each situation, and I wondered if you had an opinion on overfitting and tailoring models to a farm versus having models that apply generally to multiple farms.
Yeah.
A view on that?
Yeah, I think that is the key question, and that we're learning from. And I'd be curious to hear your thoughts on it as well at Weed Eye, how it expands. But my 2 cents on that, I would say, is it depends on how you're labeling your images to whether you can unlock the capabilities of AI to generalize. And that's a key thing we've learned. So you do see some of the networks that are touted in research. They're tested on very large data sets with very large number of classes. And these models actually perform better in those situations. So if you do restrict your usage to a specific crop, it's an interesting decision you've made. You're betting that by tightening your accuracy into that crop, you're going to get the most accuracy possible. But are you leveraging the expertise of the model you're employing? So we will find, I think, and what we're seeing is that with larger data, unlocking the data space, you can actually start to leverage these detection models for weeds the way they have been unlocked even further in other domains. So we're pretty excited to start, even for us in pasture, in Malander. So we've been testing and slowly collecting Navua sedge data in Innisfail and Ingham, and we're starting to learn exactly how we can utilize AI to get that generalization. But, and will it be better than always? So if a farmer loads up in his paddock, will he want to just select the exact season, the exact time he is in and the best model for that? Or will he get better results with a generalized data set? We still don't know the answer, but we're getting close to unlocking that. And that's it. But for now, site-specific does deliver results for maximal accuracy. So it's an interesting look to the future there, Asher. And I'd be curious to hear other people's thoughts on that issue as well.
Yeah, no, look, I think I completely agree. Excellent answer.
Cheers.
Hi.
Hey, Guy, how's it going?
Yeah, good. Maybe a question. It's on the type of model we've used. And I know it's been too short, but the odd comment as well. But like in your demonstration, it looks like you've got a image classification. I think I remember talking to about that as well. So you've got an image classification model, which makes labeling a lot easier. Whereas Guillaume, by the looks of it, is using masking and bounding blocks. Have you found any or answered more about choosing a type of architecture and the type of precision on that? Are you finding that image classification is working well, or are you moving away towards more bounding blocks?
Yeah, no, we have moved towards a broad spectrum of approaches. So we find that classification is best for certain tasks. Object detection is best for certain tasks, and segmentation is best for certain tasks. So that's what I mean by tailoring your AI to your solution. And we often feel that it does have an impact on the precision and recall metrics that you're actually measuring. So a classification model is able to learn in a different way to an object detection model. And also another interesting thing is data annotation labels are more valuable in a way for, or more impactful to model learning for object detection and segmentation. A mistake in object detection and segmentation is more disastrous for that model's output than a mistake in classification labels. So yeah, the classification does unlock speed of labeling, and it also protects you from labeling damage because it's easier to fix and annotate in the review process. But we are finding that classification does have its downsides, and object detection does have its downsides. So a broad integrated approach, given on the task you're applying, is the way to go. But yeah, it depends on your precision. In pasture, we're okay with ramping up our precision, so a little bit of overspray is okay. So we can go with a different model that you might use in crop.
Right, thank you very much, Alex. We'll draw to a close there. Appreciate your time and effort, and yeah, well done. Thanks a lot.
Thanks, guys.
But thanks for bringing me along to this one, guys. Much appreciated. Obviously, would love to be there in person, but I literally have just come back from a presentation out in East Victoria to a bunch of dairy farmers, and so we've been having a discussion about different types of spraying outside of boom sprayers and pasture spraying. One of them, actually, of big interest today has actually been fence line spraying. There's obviously new regulations coming into play where farmers spraying the grasses right next to the roads, and farmers have been approaching us. It's like, hey, can you be able to take care of that? And so we've been expanding our opportunities to be able to help out farmers in that regard. So the story of Alterratech actually starts back in 2012 with me. I have a background in economics and climatology. Basically, what I saw was the solution for the long term for improving not only the economics of on-farm situations, but also the situation of improving environmental sustainability and better stewardship of the land was going to be through a form of technology. After traveling around the world, China, the United States, and the UK, I kind of came across this idea of like, yeah, we really need to start working on making machines a little bit more smarter than they are today. And so, oh, why is this not working? So we were working with one particular farmer out near Kerrang. And they had one of these sprayers and they wanted to solve part of their problem. So we were like, all right, how do we work on this? This has obviously got a lot of proprietary hardware built inside of it. And we were like, all right, we need to work on building a solution for this one. And so we started off in March of 2019, trying to find a bunch of different things which would make this thing be able to do spot spraying and ability to do green on green at the same time. And so, oh, hold on. There we go. So we had some standards that we had to hit. It started with 20 kilometers an hour, had to be able to observe weeds at about 2 meters off the ground, and had to hit weeds of 20 millimeters in size at 98% accuracy. That 98% accuracy was basically their 2% buffer, because they understood that every time they're going to go over that field, they're going to be able to see it, spray it, and then they can come back in about a couple of weeks' time and knock that one down again with a similar type of spray. And so we basically, working around that, built a system called YAS. That's this little box here. I've got it in my hands, but I think the image probably explains it a little bit better. This is a full retrofit system. It's about 200 millimeters by 100 millimeters by about 34 millimeters in size. It's a pretty small box. It's pretty light. It's basically as solid as a stack of bricks. You can run it over with a truck and it won't die. And we built this system to actually fundamentally fit the block of these 4 things. So we were focusing on Australia, obviously, but we wanted to be able to help out farmers, Canada, United States, and see what learnings we can have from that. So at its core, it's a retrofit system. You can mount it to any sprayer. It doesn't connect to the control system. We fit actually in between the control system and the valves on the boom. So if we take, for example, the Patriot sprayer we're looking at before, it's got 50 centimeter spacing. It'll sit, a retrofit boom, mount will fit to the boom. You attach the camera to that, and there's a cable which connects to all the solenoids on the boom. So it sits in between them and will actually take over those solenoids. It's fully capable of PWM functionality for those people who are actually performing on that. So if they want to be doing a dual rate system, they can. So they do a lower concentration for the smaller weeds, and when the big weed starts appearing in the image, they can do a much more higher big splash on the much larger weeds that come around. It's also multispectral, so we identify that there's an interesting opportunity to be had in this space for infrared observations of plants. So it's a twin camera system that works in stereo, which basically gives us a better idea of crop shape, crop size, crop height, and then also obviously being able to identify weeds of different shapes and sizes. Infrared spectrum also gives us the opportunity for future things such as crop health mapping. So everyone's familiar with what we can perform with NDVI with satellites. We can basically perform the same thing in real time with this system as well. It's a fleet learning system, so every time these are used in the field, and just like our colleagues previous, we collect data, it gets sent back to the mothership through basically through 3G, 4G internet connection when it becomes available. The ability of this one is we've been able to build a hybrid system, so it uses a combination of the multispectral capability and artificial intelligence to enable to us to do green on brown, but also do a format of green on green at the same time. So where is it at the moment? It's a green on brown system. It's worked absolutely fabulously in fields at the moment. We've been able to achieve all those goals that we were talking about previous. 20 kilometers an hour, 98% accuracy with green on brown, hitting all sorts of weeds. We've been able to get like really spindly grasses as well that are quite anemic, that are facing towards the camera. Usually those are actually incredibly difficult to see because like from a side angle, seeing a thin grass is actually quite easy to see because it's covering quite a large amount of that camera. But from above, it can be very, very difficult. When you're using a multispectral approach, you can actually start identifying data bits which have not actually, which give away the presence of something being there. And that helps actually annotate our data for false positives, false negatives. We've got a green on green system set up, and we've approached it in a very different sense to standard annotation and boundary mapping. If anyone's familiar with the startup called Comma AI out of the United States, run by George Hotz, who's the guy who basically cracked the iPhone and the PlayStation, it's an autonomous car that runs off a mobile phone, and it's the most safest system in the world. They've taken a different approach to building autonomous car systems. So instead of labeling everything, they only label the things that are necessary to keep the car understanding where it is. To give you a context, an AI doesn't need to care what a traffic cone looks like. It only needs to care that the traffic cone is a hazard that it needs to avoid. It doesn't need to care about details of trees. So it doesn't include that data actually into the model. And we've done very similar into that. We've excluded complexities from our model and only included the things that are necessary to improve the accuracy of the system. And lastly, for that one, we've also created a weed mapping system, which is part of our trials that we're doing at the moment. Farmers are very interested in seeing it actually actuate on their field, but also they want to be able to see, I've just covered 200 hectares of land. Can I get an idea of where those weeds were present in my field? And if I did a walk around, would that actually look very much present to what I would experience on foot? So this is based on our trials at the moment and the data. So this is great. The bit on the left, the herbicide reduction, says 68, and that probably looks a hell of a lot lower than everyone else. That's just the current standard of what we're seeing with our green on green capability, simply because we're struggling to finalize the once canopy closure happens, and that point just before canopy closure where the algorithm does get a little bit confused. But overall, we're seeing about a 22% margin improvement for the business entirely. And in one farm, out near Kerrang, we've seen a yield improvement potentially of up to 20% based on these rough numbers. These obviously are current trial data. As we improve, that number on the left should, we want to get it all the way up to about 90%, and that margin number will actually improve as well. And so that's been very promising based on the trials that we're doing in small paddocks out in Kerrang and Horsham. And that's what brings us to here. So we have 2 farmers, 10,000 hectares a pop. That Kerrang one just got a little bit bigger as of recent news, so that's probably more looking about 15,000 hectare. We've got them deployed on a trailed sprayer out in Kerrang. It's about a 32 meter system, and the Horsham one is an Agrifac Condor, one of the new big 48 meter systems. We've got that trialing on that one as well. And we're also developed a micro sprayer, which is basically very similar to what the guys at AutoWeed have developed. A 3 meter boom, which retrofits to the back of, say, your John Deere Gator, sits onto the back of that and allows you to do your fence line spraying or a little bit of spot spraying if you need to tidy up things around the field. I was keeping this one really short. I was actually editing this one because everyone else has basically answered all the other questions and filled in all the gaps from this situation. But I'll get into the points of artificial intelligence. So our camera is a look down. It's angled slightly at about, I'll switch off the camera here so you can see my pretty face. Here we go. So we've got this camera angled, so here's the box here, and it's angled at about 10 degrees, which means it is slightly looking forward, but for the most part, it's looking straight down. And so in terms of data gathering, it probably fits quite well into the existing Weed AI data set. Obviously, the big thing here is infrared, and we've spoke about that yesterday. We're looking to generate a hell of a lot of data, and that's obviously a very big question, is if we've generated something close to 20 gigabytes of data from a single pass, because this thing's gathering data at about 20 to 30 FPS at the moment, also from 2 cameras. That does obviously introduce a significant question in terms of, what do we do with 60 gigs of data, 20 gigs of data from a single pass? We've got an onboard annotation system for this one. So basically what it does, it'll self-annotate and then it passes it back to us. And if it makes any mistakes, we correct for those annotations. If it's basically below 95%, then we will self-correct for that one. And then we'll pass that data back into the model as we go along. As I said, I was keeping it short. The other guys have basically said everything that we were going to say, and I'll leave it more open to questions as well.
Okay, thank you, Liam.
That's good, Liam. Yeah. All right. So, questions for Liam. Well, I've got a question for you. The modules that you've shown, the camera systems, what sort of area of coverage do you get? What sort of width?
Yeah. So each box is each box will represent a 2 meter field of view. That's horizontally displayed, and it's slightly decreased vertical view from that one as well. And we're getting fairly high accuracy off those ones, so that's a resolution of roughly about 1.6 megapixels. So you're going to get like pixel to millimeter level accuracy on that one.
Good.
Yeah, Liam, John Stevenson. I'm just wondering
Yeah,
about platform stability. I've seen a few videos from a few different makes today, and just wondering how reliant yours is on a stable platform as far as vertical height above your weeds.
Yeah, good question. When we did our first test, we literally ran it on the back of a Subaru Outback, and it was bumpy. With using industrial cameras, you do solve a lot of the problems of that bumpiness. They can deal with a bit of the image blur created from that if you've got a great shutter speed and frames per second. But with that said, you do get that problem of things bouncing around, things rotating, like roll, pitch, and yaw is a bit of a problem. Integrated in our system is the ability to detect for that. And so the software will actually change the way the camera operates relative to boom stability, which also helps with turn compensation, etc. We knew that that was going to be a very interesting question for a lot of people. It's like, yeah, what about turn compensation? What happens if there's minor movements? What happens if I'm going up the hill and things are changing elevation very, very quickly? So we've built in the appropriate technologies to allow the cameras to adapt to any features. So any changes of like altitude or roll or pitch or yaw created by that boom stability.
Any more questions for Glenn?
Do we have any questions online?
Well, I've got another question for you. In your green on green scenarios that you're starting to get into, are there particular crop weed combinations that you've been asked to focus on?
Everyone's going to ask for everything. If you ask enough people, they're like, oh, I've got this damn thing that needs to be taken care of, and I got this damn thing which needs to be taken care of. We focus quite broadly. The two guys that we're working with, Kerrang and Holcombe, they've got everything being a bit of a problem out there, simply because they cover so much land over so much area. And so we've been predominantly focusing on not classifying anything in particular. We've just been like, how well can we get a green on green model to work? Basically as a form of inter-row detection. And that's why I was saying it has some problems with that canopy closure. And when the canopy is fully closed, because we've built it as more of a generalized model. And that's actually been incredibly accurate. That's taken from an experiment we did back in 2019 for broccoli weed detection. A generalized model works incredibly well. It keeps your annotation super simple, and it does mean that you're using a lot more data to build that model in the first place, because you have to retrain it constantly based on that annotation data and use the training data to feed back into building a better system. So they've focused on radish and ryegrass. That's two. That's going to be expanding this year as we just collect more data. So we've got those two setups about to kick off in late April. So just at the end of April, we'll have those systems fully installed for a full green on green system test platform across those two farms. And then we'll be able to basically check what is where and see where those weeds are appearing and how we can help for that. So every time it triggers, we take a photo and on top of video footage that we're collecting, and we use that to build out the model to be a little bit more accurate in the long term.
Okay, cool. Hey.
Hey there, Liam.
G'day.
Here. So yeah, you mentioned NDVI and potentially using that as a product. I wondered if you had explored that space and fed that back to the farmers, and if they had a positive response or could use that information.
Yeah, so my previous startup that I worked at was think about it was like, it was basically Fluorosat. And so,
right. Okay.
as in I didn't work at Fluorosat, I was working on a startup that was very similar. I realized that what I'm working, like this thing was far more exciting to me than doing satellite imagery. I know I'm a hardware guy, I realized at the end of the day.
Yeah.
Farmers have loved this idea of pixel level, like millimeter pixel level NDVI, number one. But mostly it's because of this weird paradox that we have to suffer is when your crops are good, there's so many clouds you can't see them with a satellite. When your crops are bad and you don't want to see them, there's no clouds in sight.
Yeah.
And so we've literally had people saying, can I just mount a single camera to the front of my ATV and I'll just drive around, because drones just aren't at that level for them yet. And so we get this weird combination of, because we're also doing stereo, we can do a form of machine learning to get a form of like how big's the canopy as well. And so we see some very interesting research implications from the data, but some researchers are going to be like, I don't know what your data acquisition process is. I don't know if I should accept it or not. But farmers have loved this idea of being able to do in-crop NDVI. An American out in Illinois who I met way back in 2015 was like, that'll be a very interesting application for me doing liquid fertilizer application, especially in corn because it's so tall. And then interesting applications for variable rate fungicide and pesticide. Basically, the higher the NDVI concentration, the more I put down thanks to PWM nozzles. Yeah.
Cool, excellent, thank you.
No problem.
That was really good, Liam. Yeah, we've exhausted the questions here. So yeah, thank you very much for your time and for your question. That was great. Thank you.
Yeah.
Ramp it up. I'm going to hear from a leading expert in cropping systems. So to help us try and keep in context, John is going to talk us through what farmers are looking for.
Thanks, Michael. I thought I was here to dumb it down. Hopefully I am. A lot of this stuff's been way out of my head this morning. Yeah, so thank you for the invitation. a bit humbling to be the only farmer presenting. I think there's a lot of better farmers than me, but we'll see how we get on. So yeah, I'm John Stevenson. I'm the Southern Regional Manager now for the Warrakirri cropping business. We've now got 11 farms scattered around Australia from north of Geraldton all the way around the wheat belt to Dalby in Queensland. We've got roughly 120,000 hectares in production at the moment, which is a lot. Yeah, our big focus, we're a dryland grain producer, so we don't have, well, we have a couple of centre pivots, but 99% of our production is rain-based production, so a big focus on catching and retaining rain. Yeah, so every millimetre we save is, on average, going to return us about $4 a hectare. So that's every 1 millimetre of rainfall we can capture is $4 a hectare. So across our business, $500,000 every millimetre we save, which is shows its importance to us. It's massively important, that moisture. The main profit drivers of our business, obviously water is the big one. Yeah, we get a lot more value from the moisture that we store in a fallow period, so that's between harvest and planting the next crop. That deep moisture we store, where in-crop rain can give us maybe 12 to 20 kilograms per millimetre stored. The stuff that we've got at depth, it's there late season when we start running in a heat stress, it's got the capacity to give us 40 to 50 kilograms per millimetre, because it's stopping a stress point in the plant. So again, critical part of our job is just retaining moisture. We need healthy soils free of constraints, otherwise we're not going to be able to use that moisture because we've got plants that are sick and won't be able to actually capture and utilise the moisture we've got. And yield is a big driver. So we want our operations to be timely, which over that sort of area is a big challenge, both from a labour and a machinery point of view. We need robust rotations that keep our soil healthy and keep our weed management issues simple. And we need non-limited nutrition, so we need fertiliser that's there on time when it's required. And then the fourth thing fourth profit driver we've obviously got is costs, and that's where the weeds come into it. So obviously our life is all about minimising the impact of weeds, which we require the machinery and the labour to do that. Yeah, our biggest bang for the buck in weed control is in the fallow period. Our most expensive weed control is in crop, and that's where you guys are focusing with your grain on grain technologies, trying to help us minimise the cost in crop. So whereas a broadacre application with this boom spray in a fallow period, we might be able to do it, including machine, for $12 or $13 a hectare. Typically, some of the more specialised in-crop applications, we could be spending $50 to $60 a hectare. So it's a fivefold increase in cost. So the challenges that we've got with our weed control, that canola crop that I'm spraying there is shoulder high. So can you imagine trying to target a ryegrass plant on the ground 4 foot below my shoulder? That's going to be a massive challenge for any chemical in any system. But yeah, relying on chemicals that have got a declining level of efficacy is one of our biggest challenges, and that's the resistance part of the weed management spectrum. Weeds evolve, evolution is what it is, and if we have 1% of our weed population survive every time we apply a chemical, they breed. It might be 3% next time, might be 9% next time. So that's obviously a very big challenge. Limited choice of crops by environment. So I can't grow hemp, it won't work. We're very limited to what we can grow. I have acid soils which don't suit a lot of pulse crops. So chickpeas and lentils aren't an easy crop for me to grow where they are in Victoria on a neutral soil type. So by region around Australia, you've got very different crop choices and very different weed control issues within that region because of the crop type. Obviously, if that canola crop in that photo was a lentil crop, it would be about 200 millimetres tall. and there would be a lot of weeds poking through the top of it, which would be easy to see. So it's yeah, a different environment. Yeah, transient windborne weeds are a big issue for us. We've got feathertop roads, we've got south thistle, milk thistle, we've got fleabane, we've got hairy panic. Are probably the 4 main weeds in our region that I think would be the biggest challenge. And they will come in from miles away on the wind and be deposited randomly throughout the farm. So they could be dispersed over 100% of the farm, or depending on the wind direction, or 25% of the farm. It changes year to year. And it's often a legacy of neighbours who probably aren't as fussy about weed control as we are, who let things get to seed. And then narrow row crop spacing. So we've gone to narrow row crop spacings, and yeah, that canopy closure is much similar than it would have been traditionally. So the overhead crops you just saw in the Alterra presentation prior, you could actually see down in the canopy that would have been Jeff Reapers on 12 or 13-inch row spacing, where we're half that row spacing, and our canopy closes in probably in a third of the time. It's not a linear thing, it closes in a lot earlier. There's some of our challenges. The narrow row spacing is also one of our wins, because it's actually out-competed the weeds, the crop earlier. So that's our aim with the narrow row spacing, is to get that exposed ground covered over, so that the germinating weed's got no access to sunlight, and it has a tendency to sit dormant and go, well, I've got no light, or if it does germinate, it's going to be very uncompetitive and hopefully settle off this seed and otherwise. The green on brown optical sprayers have been a massive win for our business, particularly on farms where we have a lot of fallow, as in northern New South Wales, southern Queensland, also around the Merredin area in Western Australia, and probably on the new farm we've got up at Una. Where we have a lot of fallow, obviously we have long periods without crop, and particularly in the northern New South Wales, southern Queensland, they all alternate between summer and winter crop. So the optical sprayers up there basically don't stop year round. When they get back to the start, they go again. They just go round and round and keep spraying. We've seen some very big return on investment numbers from running optical spray technologies. As we discussed yesterday out on farm, the biggest challenge is labour. It's not an exciting job. Autonomy has some exciting potential in that field, but it's pretty hard to keep staff motivated to keep jumping on the weed. It just doesn't stop. You just keep going. Particularly with big tanks, like the 6,000 litre tank on that haze set up on the screen there. You know, in light rate applications that could last for 3 days. You just need to manage staff to reduce fatigue, and fatigue inevitably leads to errors. So it's all about keeping that thing going. I mean, the challenge for the autonomy though is the whole monitoring scene. Like camera lenses need to be cleaned of dust. Nozzles need to be checked for operation. Computer might tell you they're opening, but nothing may be coming out. So it's it's a machine. It's mechanical. Without sufficient feedback data, there's no real way of telling whether things are all functioning well. And then the harvest weed seed control is another big win that we've had. We were in a paddock yesterday where they were using the mechanical mill. So in that situation, they're grinding the seed into a flour, essentially, which is killing the seed. We haven't gone there yet. We have big harvester fleets with our areas, and at $100,000 per machine, it's a massive investment for our contractors. It's a bit too much to chew off at the moment. So we've just gone to capturing that weed seed and putting it into our wheel tracks with chaff decks at the moment on most farms. It's been a great win for the non-transient weeds like your ryegrass and your wild radish that will hold the seed on the plant well. But for shedding weeds like wild oats tend to drop their seed, or windborne, south thistle, etc., probably not very effective because it's already gone before the harvest comes through to collect it. But yeah, the optical spray has been a fantastic invention. So to the future and what's required, well, on our scale, it's reasonably impractical to think that we're going to get the capacity to get over 120,000 hectares in a timely fashion to control weeds and not go broke trying to do it. It's going to require massive amounts of capital to try and cover that area well, particularly the speeds, and just imagine the amount of data from 120,000 hectares to process as far as capturing weeds. Yeah, I think we probably need to use other passes over the farm to try and build data sets. And even if it's only collecting a metre wide swath on a 36 metre machine every time the machine passes over, if you can build a data set of where the weeds are, so you can be more targeted where you use your green on green gear, I think there would be some big wins there. It's not all about collecting every metre of every paddock. I think just representative data sets will go a long way on the scale that we're on. We have to determine, are there other non-visual means of sensing weeds? We've actually tried using satellite imagery and done it reasonably well to capture areas of ryegrass in the crop. As you can see, plant density over that area, but again, you're restricted by clouds. So do we use drones, NDVI, things like that? As we were talking about yesterday, can you get machines to smell where weeds are? Is there things when you can't see them, how do you detect them? Yeah, are there other ways of looking at the crop? So if you're in a lentil or a chickpea crop and all the weeds are taller than the crop, should we be looking sideways, not down? Because that might be a much easier way to see it. So anything above 200 millimetres high, trigger a spray. So it's just all about perspective and how you look at problems. And then can we get artificial intelligence to ignore the row crop, the crop row itself? So can we say, okay, I know this crop row should be 150 millimetres wide. It's this green. Let's just ignore that. Anything that's not within that row, let's trigger a nozzle. So I don't know the answers. You guys are way smarter than I am. So I'm only here to tell you the problems. So anyway, that's about all I've got for you. Any questions?
Yeah. There's some background on your the capital approach to machines. Spoke about the challenges, so how it working.
Yeah. So Garth just Garth just asked about our approach to investing in machinery, and I guess we are here because of a very good investment, Rest Superannuation. We base most of our decisions on financial return capabilities, so we have target operational returns of a little bit over 5%, and we run CapEx models to try and replicate that scenario. So if we're looking at a green on green spray, it is quite hard to model. I know with the green on brown stuff, it took us a couple of years to get our head around it because we actually needed feedback from the field to say what were we spraying and what rates were we using before we could actually analyse it. But yeah, basically all our machinery investment decisions are based on return on investment.
Yeah, so you talked about driver fatigue. Have you looked at the SwarmFarm approach of autonomous vehicles that are almost operating continuously through fellow scenarios as a way of maybe overcoming that? Maybe better route control?
Yeah, so Michael just asked about SwarmFarm and have we looked at using that technology? Certainly looking hard at it. Again, it's all about trying to balance cost and benefit. I can see that we could probably justify a fleet of SwarmFarm machines and actually move them around our 4 northern New South Wales farms as a fleet. And that would be very labour efficient because instead of going out to fill up 1 machine, you're going out to fill up 4. So rather than having 4 farms filling 4 machines daily, because you've still got to monitor, you've still got to fill them up, you've still got to be present there. But certainly on the fatigue front, I think the SwarmFarm system has got a lot of potential. But again, it comes at a price, and we've just got to make sure that's the right price for us.
Oh,
Yeah, John, really interested if you could expand on a couple of those dot points up there, because the argument I have in my head goes round and round about mapping weed hotspots. Okay, so you see the weeds there, that probably set seedenscape, so it might be there next year, but then how do you factor in dormancy? They're going to actually come up next year. And then, of course, you've got weeds moving anyway, moving in, transient weeds, and even some of those other weeds which don't move that much, but they still move.
Yeah.
So I'm always, I never come to an answer. Is knowing those hot spots really valuable?
I think, so Jason starts about, is knowing the hotspots valuable from a weed management point of view? I think it's really a live thing. I don't think you could base this year's decisions on last year's weed patches, but I think you could certainly base this year's decisions on the past, the fertiliser spreader made a month ago. So I'm probably saying a month is good history, but a year maybe not so.
Also, adding, all those references back to other data
yeah,
finding those trends in weed densities with other data is you can start to apply those theories.
Matt just added that there's multiple layers that would add value to.
There's no, especially if we know, the low down. What sort of eligible crop are they? What do they call it? They're very long canopy. So Guy just asked about the very tall crops like canola, the low down crops, what impact have they had on the crop and what's their control. So really they're only there for harvest weed seed control now. That's the only technique we've really got. So we'll go in over the top of the glyphosate as a late crop top, and then we'll collect the seeds in the chart lines. They don't have a big impact on your canola crop, but the whole purpose of our broadleaf crops, our canola crop and our pulse crops, is to try and take no prisoners in that phase, because those weeds are going to be there in our cereal phases when they have their biggest impact. So, but you want to try and get through with a clean canola pulse rotation to give you that weed-free couple of years in cereals.
Following up on that with the denser spacing, what's your critical window then in terms of control beyond which it's too crowded?
Yeah, Asher just asked about what's the window for weed control with the narrow row spacings. If you want to do it in a cost-effective manner, you've got to do it prior to canopy closure. So you've really probably only got 3 to 4 weeks post-emergence to do that, but you've got to wait till the crop is safe enough to spray, which has limitations as well as far as a safety window for application of some chemicals. So you've got this balance between the chemical not hurting the crop, but also getting good control on the weeds.
Steve, you mentioned big crop types that do flows quicker. You're actually starting to go the other way now, really on down, so you've got an opportunity to spray.
Matt just asked about selecting varieties that do stay open in the canopy rather than closing in. But look, I think that competitiveness is gold. I don't think we want to leave sunlight hitting the ground. It's just encouraging more weeds to germinate.
So we do have a question online from Vicky. She says, we've heard today that these technologies will allow us to use less chemicals with each pass. It may require more passes. We hear all the time growers don't have enough spray hours in the day. How practical are more passes for water theory?
Yeah, thanks. Vicky, I did see that brought up earlier with the more passes, and I had a bit of a smile thing, which is we struggle to do the passes at the moment. But it certainly makes a lot of sense. And I know even from the green on brown spraying that we do, you've just got to do multiple passes, and often from the opposite direction too. So you don't spray the same direction every time. You rotate a north to a south, because the shaded weeds won't be shaded from the other direction. How practical more passes going to be for us, and I think that's where you get into autonomous technology. I think we have to be very conscious of developing spray application technology that allows us to open the windows a little bit more, because as we become more regulated, the rules around when we can spray and what we can spray with and what that droplet spectrum can look like, and the whole risk of inversion layers and spray drift really do close up our windows. So even if you get to the autonomous level, the thought of it being able to run 24 hours a day, that's a pretty slim chance because the environmental conditions just won't suit.
And I agree with you on that part of regulation. Regulation is government or culture. We're only pretty expensive in the area. And we use the right production technology. Is it not an opportunity like good in 30 years? It's great.
Yeah. Garth just asked whether this technology, being only 10% or thereabouts of the past, whether we can actually stretch those windows. And I think that's something that we'll have to work with the regulators to do. I think often we live in a world of lowest common denominators, and we have to cater for those who aren't doing the right thing. But unfortunately, everyone else who is doing the right thing pay the price at the end of the day. But compliance is compliance. From our point of view, we can't stretch the compliance window.
Yeah, I've got a question along the same lines. So, if you've got autonomous platforms that have got cameras on them and they're doing in-crop monitoring, what is the benefit, if any, of in-crop monitoring in the season being used?
You might just ask about what is the benefit of monitoring in-crop. I think there's probably potential to be doing multiple jobs as well as in-crop. I think we could actually be doing crop health as well with that same pass. But yeah, literally, like on our scale, I've got paddocks that are 1,800 hectares, and as an operator, I might only get one pass over that a year. So we don't have the same sets of eyes running over those fields pass after pass. So we don't have that developed knowledge, that intimate knowledge of paddocks, especially over that size. I mean, that's sometimes 3 people's farms, 1,800 hectares, and we've got to get one paddock. So I think from our point, being able to make it a good mud map of where we've got issues, one, it helps the agronomists go there to check what's going on, but also if we do get to needing to use expensive sprays, it would allow us to go back even broadacre back and hit those patches, patch it out. Because if you've only got 15% of a 1,800 hectare block affected, and you're running around with a $45 a hectare spray, there's a lot of wasted application, wasted cost.
Jason's point on exactly that. Green, or onto the 18,000 spraying, what where the target for that components, all of those.
All right. Liam does have a question online. So Liam, if you can unmute yourself.
Yeah, thanks. It's just I have one question around your thoughts of variable rate. Some folks out in Canada or even here in Australia are pretty cool with this idea that you can put a low rate down on the smaller weeds, and when you find a much bigger weed or a larger concentration of weeds, you start really doubling down on that concentration in that particular area. I'm just interested in your thoughts on that.
So, Liam, are you referring to our current green on brown, or are you talking potential for green on green as well?
I'd say both. A lot of the conversation is obviously around green on brown because we're seeing the weeders and the weed seekers now springing up around Canada, Australia, and the United States. But it'll be interesting to get your perceptions on green on green as well. Yeah,
with the green on brown, our current experience is that when we've tried to run the dual boom, because we have dual boom on all of our units, so we can run the broadcast and the spot spray simultaneously. When we've tried to do that, the time it takes to get over the farm, because you are speed limited, by the time we get to the far end of the farm, those small weeds are big weeds. So we tend to just run out with the broadacre boom and get that job done quickly, and then come back and mop up with the spot spray and use the full tank capacity to extend its capacity. So we can run out a 500 mil rate of a glyphosate CT, smack all the volunteer stuff quickly and effectively, and use non-volatile products. So you can use your 2,4-Ds in your weeder when you've got good drift control and slow speeds, and just get the main bulk of the work done quickly with the broadacre boom. And thinking out loud, I think there's still good opportunity to do that in crop. So an MCPA LVE rotor mix is not a big cost. You can hit small weeds effectively and quickly with the broadacre boom. And I think that the time limitations you have to try and do broadacre work with weeder, when we've already seen today, small weeds are a big limitation for ID. So it's it's going to be a big challenge to beat the economics of just getting the job done in a timely fashion. Particularly in this southern environment. Like when we get into winter, we can have long, wet weather events. We can have month delays and paddock accessibility if it gets wet, and you just can't afford to leave it sitting there over that period of time.
Cheers for that.
Okay, we'll wrap that up. Thanks, John. So that was really good. That's brought us back to the field. And so next up.
All right, for those that don't know me, my name is Garth Wickson. I currently work for Syngenta. I look after the selective herbicide portfolio for the business. For the last 25 years, I've worked for an R&D organisation such as Syngenta. I've been with Syngenta for 17 years. Before that, I was with BASF. I started out in the R&D space, moved into market development, and now in a commercial management role. So my role is really engaging with our global team, understanding what we've got from a new tech perspective, getting the business cases up to support the development of those products in an Australian context, and then seeing those products through to commercial release and ongoing sales in that scenario. So do the full gamut, and part of my role is trying to understand what's going on in all the relevant areas so I can then forecast what's going to happen from a supply perspective. So the first piece I wanted to comment on was what's Syngenta's view on site-specific weed management, and more specifically the green-on-green piece. And the first response is challenged. I've heard nothing but negatives from a business perspective for us. You guys have all been talking about significant reductions in chemical sales, etc., which is clearly a little challenging. We're in the business of selling product, let's be clear. However, and all jokes aside, and that was a little bit of a joke in that context, from our end, we see significant opportunity. There's a significant change in the way in which things are being managed. And as a consequence, there's a number of opportunities for businesses like ours. A couple I've called out, and I'll touch on: stewardship, go-to-market, and ultimate chemistry. So first of all, from a stewardship perspective, obviously one of the key benefits of this type of technology is the reduction in the AI that's going into the environment. So if you look on a global basis, and even here in APAC, even in Australia, we've got the same desire. We're losing chemistry or grower weed control options as a function of regulation, etc. Part of that is driven by the amount of AI that's ending up in the environment. So this sort of technology enables us to continue to offer this type of chemistry, or some of this chemistry, to growers as a tool to control weeds and maintain its place, but at the same time minimising the exposure. So if you think of contamination of waterways, off-target drift, all of those sort of things, there's a strong benefit associated with this. In addition to that, there is the amount of chemistry that's actually going on to commodities that we're consuming. So instead of sort of having to apply an MRL across an entire crop or scenario, this would allow some variation. So there's some work to be done in terms of how that plays out on a global basis, but absolutely there are significant benefits in the opportunity for us to continue to offer the current range of chemistry into the marketplace. Second of all, obviously, traditionally businesses like ourselves are seen very much as input suppliers. So we supply a product which you growers then go and use to create an outcome. One of the ultimate discussions that we've had internally around this sort of technology is it may allow us to shift our go-to-market model and focus more on outcome-orientated approaches. So that's more of a longer-term goal, but certainly something that potentially could
come to the fore as part of this approach. And then finally, and not finally, I should say that the third one I quickly wanted to touch on was this ultimate chemistry piece. So what we've seen with the introduction of green on brown is initially a change in the amount of non-selectives that are being used. So we saw reductions in, like say, the paraquat because of not only spraying a smaller area. But what we've seen is also a change in the way that chemistry is used through that type of technology. And as a consequence, it's creating other opportunities for placement of products and utilisation for whether it's resistance management or overall weed control. So using our current portfolio of products, this technology allows us to place them in different areas. Looking forward though, the real opportunity is then assessing how we develop products. This type of technology has been touched on a couple of times today and yesterday, that there are different opportunities and approaches required, and as a consequence, what we develop as an R&D organisation can differ to suit that scenario. From a Syngenta perspective, I'm aware of 2 compounds, one a non-selective, one a selective, that we're currently working on developing globally, specifically for this type of technology. Traditionally, it was, right, it's a broadcast application, where's it fit? Now we've got, we are looking at the opportunity for specific chemistry, which may be because of cost, it may be because of regulatory restraints. There's a number of barriers to entry that this technology will allow us to address. So, in summary, from our perspective, Syngenta sees some significant opportunities in this type of technology. Helps us with some of our challenges and potentially increases the opportunities for growers to utilise different approaches to manage things like resistance and residue levels moving forward. I'll skip through this one quickly, but in summary, this is just a pictorial view. Syngenta sees themselves as involved in supplying grower needs or part of that process. We're actively engaged in the CP front, obviously. We interact with a range of machinery and application specialists. We develop nozzles specifically to deliver the best results for our products. And we see that the introduction of this technology or continued introduction as part of that process. And we just see ourselves as part of the cog in the wheel in terms of delivering the tools for growers to ensure that they can control or manage the weeds in this instance. Looking forward, what's our involvement? And I suppose what I want to do now is quickly step back and sort of paint a bit of a picture around site-specific weed management or this type of technology and where that fits in terms of the businesses. Now, before you all gasp, yes, this is a Bayer slide. Yes, I work for Syngenta, but I put it up for a specific reason, just to highlight that I think a lot of the R&D companies are fairly well aligned with this approach. So this is a presentation, out of a presentation that was from Bayer's capital markets presentation back in early March. Most R&D organisations will present this sort of material, and it's a summary of where we see the businesses going over the time frame. And this is just looking at their R&D pipeline. So when most people think about the likes of Syngenta, Bayer, BASF, the likes of FMC, etc., they think of us as chemistry companies. A lot of people see us as, well, we develop chemistry to go and control weeds or pests or whatever in that context. But as most people are aware, we're also involved in breeding, so we're generating varieties. We've also got a biotech unit focused on traits. We do have the chemistry portion, and we have a new and emerging areas like biologicals, which is a key focus for a lot of the big R&D businesses. But the key piece for me, and in regards to this discussion, is this fifth pillar, digital ag. Now, whether it's ourselves, Bayer, BASF, etc., quite often you'll see this being called out. So if it's being called out at this level, it's clearly a significant area of importance and focus, not only from an R&D perspective, but also from a commercial output perspective. So I just wanted to reinforce that it's certainly part of what we do is thinking about this space. Now, obviously this space is, when we talk about digital ag, is highly complex and there's lots of elements, it's platforms, it's various different bits and pieces. And this simple column here is, in a lot of cases, trying to encapsulate where we're involved in all of this in various areas. And you can imagine from John's perspective, how does he take all of that, make some sense of it? I'm sure he'd love to have a black machine like this spoke somebody, I don't know. But, and then work out what's best for him in that scenario. And quickly, this is a bit of a plug from a Syngenta perspective. What Syngenta's trying to do is funnel all this down into some core funnels. So this is our digital ag type brand, and then within that we have our relevant pillars that have the relevant components. So whether it's focused on financial, risk management, planning, sustainability, etc., a grower can then look at that relevant area. Within this is this type of technology. So the next question is, what's our level of involvement? So if you look at the right pillar and the right sliver of that pillar, this is a quick snapshot or overview of Syngenta's involvement in this area in 2020. So again, I'm talking on a global basis. Obviously, the relationship and the interaction varies by territory, by company, by circumstance. So obviously, we're involved with a lot of the machinery operators, whether it's John Deere, Case, etc. We have relationships with those and interact with them in their relevant developments and how we fit in that place. As you move into more of the sensors and software, as we've been talking about in the last little bit, we're across a whole range of players in this space as well. And that can be as basic as having a relationship. So we sit down and have discussions around what are they developing, where is it going, how can we interact through actual investment. So some of you will be aware that Syngenta was financially involved with Blue River originally. They've moved on from that. And as it currently stands, we have a financial position in Green Eye. So Green Eye is another similar organisation based overseas and in the process of launching green on brown, green on green technology throughout the US in the near future. That's a bit of a snapshot of our level of involvement. The next piece is, what are we doing from a development perspective, or how are we engaging with these people? Quickly, from my end, again, depending on the partner, the technology and the circumstance, we work with them to test the program that they're running, or the hardware, the software, the algorithms, and combine that with our products in that scenario. So trying to understand, if they're using this type of approach, how does it work from a CP perspective, how does it fit together? That then gets utilised. I apologise for the photos. But we also then take that information and develop digital simulations so that we can then support our chemists. So we've got a facility in Gels Hill in the UK, solely focused or dedicated on developing products. They take this sort of background information and that helps them understand what they need to do to develop chemistry or the product to deliver or support the need of the technology in that scenario. So it's a fairly well-connected chain. It varies by country, as I said before. We have everything from financial investment through to just an open dialogue discussion. We're actively working in a number of markets with varying levels of technology, and that's being fed back into our base chemistry development, which, as I said at the start, we've already got a couple of potential products that will fit or are tailored specifically for this sort of technology for future use. And bear in mind, some of that is still a couple of years away or several years away, but it is certainly something that's part of what we're doing moving forward. Questions? That was just a quick summary. Hopefully that was what you're looking for. Really just wanted to demonstrate that, yes, we are absolutely acknowledge that we are changing usage of chemistry, but there are significant opportunities associated with that for a business like ourselves. We're actively working in this space and continue to do so as we go forward into the future. Thank you for your time.
Garth, as we start using your products for alternative technologies like optical sprays, who's paying the registration costs to get that on label? Is it something you guys have to fund?
Yeah, so the question was essentially around who's paying for the registration costs associated with the product. Well, absolutely, it's the individual registrant in that scenario. So, as we choose to register a product for that type of technology, it will be us that has to develop the work and do the work to develop the package to submit to the regulators in that context. So whether it's ourselves or New Farm or whoever.
And it's the same for existing old technology like Paraquat.
Yep. There are obviously varying levels of requirements for registration. So if you've got an existing product in the market and you want to register for this type of technology, if there's a change in rate or application timing or those sort of things, that'll be a more significant change. Whereas if all you're doing is putting on a different type of application, it may require a lower level of work in that scenario. So the real challenge or question becomes is if you want to increase the rate above the current labour rate or the gap rate with agricultural practice rate, which is where residues and those sort of things are set. And I think that's probably the unanswered question for me over the last couple of days. Things when we talk about multiple applications, straight away I'm thinking, well, hang on, we've got upper limits in terms of applications or total AI, and we need to understand what that means as we move forward. Very good.
Have you found the regulators relatively cooperative in that regard? Are they moving with technology and with expectations, or are they a bit lagging behind somewhat?
They're doing a wonderful job. Look, to be honest, we've engaged and probably New Farm's done more of it than we have. We've got our paraquats registered for green on brown applications. And we've held discussions with them around green on green registrations, and certainly I know Bayer and others are doing the same. They're learning the process at present, and probably the ask of the industry is really, I encourage you to go and have the discussions with regulators. You may not be registering the products, but they need to understand what the technology is going to do to then build the regulations. So the more information sharing we can have, the better they will understand the circumstances. So they're absolutely open to it, but they're on the learning journey like we are in terms of how this works from a regulatory perspective. All right.
Before you go, can you get your Garth's presentation back up again? There's just something I wanted to point out in terms of how I see the herbicide companies fitting. So we'll cycle back to the third or fourth slide, I think it was, the one where there's some Syngenta sitting in the middle. Yeah, this one here. Right, so if you sort of put research over there, or weed control researchers, that's where we sit over here. In terms of getting what we develop to the grower, there's a blank space there. So if we, for example, come up with laser weed control technologies that have proven to be highly effective, and we can publish those results, there is no one available who is going to take that weed control technology through to the market. Are you going to do it? Are you?
I'm out.
Well, I can get your name there. And that applies not only just for new weed control technology, but weed control technologies in general. There's a gap here that the herbicide companies currently sit in. They do it beautifully well for herbicides, so any new herbicide product that comes to market, there's this whole machine that can just take that right through to the grower, work with the grower, get the grower to use it, etc. Offer all that after sales support. At the moment, we haven't got that from our weed control technology. And I guess I kept nagging Garth and other herbicide company reps. Let's just not be herbicide companies anymore. Let's be weed control companies. Expand your portfolios of activities, and yeah.
So in response to that, what I'd suggest is that you can look at this piece as an example, and this one. If you go back in time, a lot of these companies were just this, or they were this. We understand the market's changing at a global level, and it's about understanding where the opportunities lie. And that's the key challenge. It's a business case. At the end of the day, we're a business like farmers, like a lot of people. We need to understand what the opportunity is. So if you can present the case sufficiently, we're happy to expand, or there's willingness. That's about it.
Yep. That's very encouraging.
They're my comments and my views, and obviously the people above me that like to make some decisions. But
yeah. All right. So we need to take business cases to you guys to.
Absolutely. There's got to be a discussion, and I come back to this point here. We're interacting with all of these people. You've got to have a conversation, and while we're investing in Jourdain, while we invested in Blue River, part of it's about learning and understanding. Where is this technology going to go? How is it going to impact the other parts of the business? What are the opportunities for us to develop it and take it forward? So, you need to get a seat at the table, have the conversation, and present it forward. Yeah. Yeah, so again, I'm going to come back.
Yeah, which I think is, well, I mean, it's a challenge, but it's not, that's, I don't think it's impossible.
You've got to be able to demonstrate what the opportunity might look like. Sure. So, I mean, this is the R&D work slate for Bayer as an example. I can't remember the number of it. It's $2.2 billion that's into this annually. We do 1.2 in terms of an R&D investment. There is significant funding on an annual basis to invest in that context, but you've got to have the business case that stacks up accordingly. And that's what I'm saying with the digital ag piece, we're heavily involved in this area, but it's platforms, it's FMS, it's about making sure you get your own little box in this space and making it relevant, not specifically that box, but make sure you're relevant in that context and have the conversation. To be honest, part of the reason I'm here today is to understand where this technology is at, getting another piece of information we can have that conversation, and that's happening globally.
We do just have another question from Liam. So Liam, if you just want to unmute yourself.
Yeah, this is two questions. The first one is this area is moving very quickly, not only with like the application technology and the sensing technology, but we're seeing all sorts of other stuff come out at the same time. So what are like the large concerns that you're considering that are from the not direct but indirect, because there's sometimes the ones that can sideswipe you. The other one is, what's the general viewpoint of Asia Pacific? Obviously you don't have, you know, it can be like an $80 billion chemical market, but we're also looking at the terrain is different, the crops are obviously very different, and the scale is different. You have a lot of smallholder farms. So just, if we jump over those two, that'd be great.
Yes, I'll answer the first one second. Essentially, in terms of APAC, obviously, yes, a lot of smallholder farms, a lot of knapsack applications. So that's where drone applications is really starting to take place, and we're involved where we can in that sort of scenario. So yes, it's a very different situation, but you know, digital as a whole has a place to play. It just looks a lot different to what it does in North America or Europe, and the drivers sometimes a little bit different, but they're also very much aligned. You know, as an example, you know, we've lost paraquat. Growers have lost the opportunity to use paraquat in Europe, but they've also lost it in Thailand. And we're actively fighting to maintain and support the use of the product in markets like Australia. So there are some significant differences, but there are some underlying similarities which drive the interest in investing in this space. Going back to the first question, you know, there are things that concern us, and the example I gave before was, you know, some of this technology looks fantastic, it looks great, it allows us to reduce the total chemistry application, but understanding how it's actually then going to be applied in field. So, you know, the residue implications, the regulations around registration, making sure we meet all of those. Obviously, the concern is that we shift to a different approach and we just generate other problems that we currently can't foresee or, you know, haven't worked through because we aren't connected sufficiently between each of the components and technology. So the CP supplier or the weed control piece, the application technology, etc. If that answers it specifically, but yeah.
Yeah, that's cool. Thank you.
All right. Thanks, everyone. Appreciate it, Tom.
Thank you very much, Garth. The purpose of this discussion now is to, I guess, try and get us a little bit of focus on what's going to happen next or what needs to happen next. And so I thought I'd start with just a couple of slides. First of all, just outline what our overall objective is. So us as weed researchers, our overall objective is to create season-long in-crop site-specific weed control opportunities. Okay, so even though growers might have specific weed control timing targets, different weed species preferences, different cropping preferences, us as researchers want to make sure that there's opportunities for everyone, for every scenario in crop production system and grain production system in general. So that's a far bigger thing than just focusing on, say, 10 weeds, south of 70 chickpeas, So what that means is that we need to develop the recognition capacity for all those combinations. So species differences, growth stage differences, different environments. So that's a big ask. But I think if we're going to be serious about it, we need to have this quite large objective. Okay, so that's our thinking. Now, that doesn't mean we have to do everything all at once. I guess the thing we need to do through this section is to figure out how we can achieve, at least to start achieving parts of it. And then I'll just put this down here to indicate that this is also a bit of a global challenge. So we're starting to get attract global attention. So I think we can quite comfortably say that we're probably the only ones who are really looking at this seriously. So from what we've been doing, we're starting to get interest from researchers in the US and Europe, reaching out to us saying, okay, you're going with this, we're thinking about similar approaches, how you were tackling the approach, can you work with us, can we work with you, type of thing. So I think there's some really good international opportunities that are coming out of this where we can tap into other resources, lots of collaborations that can actually streamline some of the things that we're trying to achieve. So I think it's good that we're in many ways leading the charge. There's obviously some challenges in that. But I think for us in Australia, we've got a real opportunity to, because of the attitudes of the growers in particular who want to see these developments, that sort of motivates us to continue focusing on these challenges, and then obviously it's attracting international attention to see this. So I think we're really exposed.
We do have a comment from Andrew there. Perhaps another capacity factor is the ability for those recognition approaches to facilitate different weed control technologies.
Yeah. All right, so now we need to start looking at some of the challenges, the specific challenges that we've got. And this is where we need to collectively set them up. Some of those things. Maybe you're prepared to type in some of the things that we got there.
I might move this over there. Just turn the sound off so that I'm turning the full. Just so that. If people online want to participate, just shout out now.
Right, Guy, you're probably the expert, one with the most experience on image collection as far as cameras go. So, yeah, are they, well, first line, is that the right questions? Which is more important than others?
I think we're going through these probably not to be too prescriptive, like as we've seen with Alex Olsen, his approach has been to do a separate approach for individual use cases, and perhaps for each or different crops there might be different specifications. What is probably most important is being consistent in how things are collected and reporting how it is collected. So if you want to use data for a specific purpose or collect it for a specific purpose, there's a standard way of reporting that, which is, I guess, what we'll try to do with the WeedAI platform, because that really hasn't existed before. So are we trying to work out who's going to collect it or who's going to?
Well, I think so. We need to probably identify the challenges first, and then through that process, we'll figure out who can address those challenges.
So that's a big challenge for the first, for lots of this, is that there isn't clear-cut research for clear benefits for each angle or resolution or image heights. It tends to be by crop type or by approach. So that's one of the challenges. There's no real clarity on how any of these things should be used, because there are advantages and disadvantages of each, and depending on how you set up your company or your approach, those disadvantages and advantages will have different weightings. So that's probably the first challenge.
I suppose, like we see that different applications require different solutions. If you've got fallow, it's very different to having high stubble.
Yeah.
In terms of how you might set that up, which is problematic for people designing products, I suppose. It tends to be easier to design to one scenario.
So I mean, I guess in that, from what Guy has said, the questions are really research questions. So the solution at this stage is more research. So,
and also enough data for each of those. Like at the moment, there is no public data that I can access that has comparative heights or comparative lighting conditions or comparative resolutions. So there needs to be more data available for each of those use cases. It isn't privately held, so that these comparisons can be made.
Yeah, I think that one of the things is we've seen this success from the industry friends here who presented some amazing stuff that they've been able to work on. But the thing is, they've been developing their algorithms, their data collection, and the equipment as well, the use case all integrated together. I think what's kind of the challenge here is that we need to, we're talking about collecting those images and building up that data set ourselves. We need to account for all the potential applications that it could have. And so there's really a lot of variables we need to consider. Just, I mean, the simple thing I'd say is we want more, as much as possible, as much data as we can possibly get.
So I think the data collection is the issue. Like it collects stacks of data, it's annotates it.
That's the other part. Yeah.
I think saying we need more research and more data is an obvious solution. We need to get a bit more specific.
It's not a solution. I guess it's really a problem. Yeah.
I think going a bit further down into the data collection is so saying data collection. So like it's easy to get the data is true, but how do you actually then engage with farmers or engage with companies who are building sprayers or whatever to have these data collections mounted? And is there a need to develop a specific data collection unit that can be mounted to any sort of conditions and be used in a whole range of different ways with the variability of angles, heights, lighting, whatever, that we can, so we can test these things. So maybe that's the more specific solution, is to look at developing a universal data collection unit.
Yeah,
standard.
Yeah. I mean, if we had a standard thing that we had right now that we could put on, yeah, people would use it, right?
With sign-up through research farms where you could go and bolt it on with the spray farms. And I think that's a more controlled environment somewhat, and it's a more steady environment that you can start off on. I think just guaranteeing against the farmer, you'll get a million images, and it's how you collect those images too. Be able to turn it on when you're in a paddock that's going to collect the data, and some of the parameters around how to collect the data for growers or researchers. GRDC is a classic example. They've got a million plot trials each year where they're engaged with people to run NVTs.
NVTs, for example.
Just to have, taking photos of the weeds that emerge. We've got Magenta run trials and Bayer run trials where they're actively trying to get weeds to grow. It's just the standard of collecting the data, I think, is one of the most important things.
All right, so there's quite a few variables up there about angle, height, lighting. Can we have some best bet approaches to some of those? Because we start with multiple combinations, which are rather expensive research programs. So can we use what we know now from knowledge of engineers and whatever? Can we have some best bets? Can we just say, okay, let's use a 10-degree angle, with some sort of surety that's going to work. Worrying about testing will be.
I'd say 90 and well straight down and 45 would cover a multiple wash.
The unit that the guy is talking about could easily have multiple cameras. So you could have both. And that unit could just automatically label every image with splitting bits of metadata.
There's a technique, I've spoken to Guy Coleman about this one before. And what we do is we actually have a system constantly collecting data. And it's basically the model's constantly running. And the idea is to prevent a situation where you're collecting more data than you actually need. So for example, if you have a model that's incredibly good in a particular context, say identifying a particular broadleaf weed, you don't really need more data for it. If the confidence is super high, you want to collect for where the confidence is super low. So what we've done is we collect data where the confidence is low, and we use that to actually improve the system overall. It's otherwise known as a technique called active learning. So if you think about like a normalized distribution, your x-axis almost trends to infinity, your y-axis trends to 100%. You look at the area above the curve to collect data for rather than the area below the curve. That will obviously help satisfy moving a lot faster. Most papers released on this have shown a 75% decrease in data requirements, while still maintaining model accuracy to be about the same, if give or take 1%. So that's what we're doing with our system at the moment. So it's got NVIDIA core cameras, and it'll basically collect and pick and choose data based on its confidence level, and it'll just send it back over 4G to the mothership.
So that's a good way, I guess, if you have data already, and if we're provided with lots of data to start with, but we still need to get that initial set. And particularly because we have the, as you mentioned, Michael, the every crop weed combination growth stage environment. If you had a model for each of those, then you could start to do what Ian's talking about. But in the outset, you do need a large amount of data.
And so more about the metadata, is that really important?
Metadata is important for future comparison, so we can actually do these testing. So as long as you report how you collected it, then you can start to group things and then perform tests because it's all standardized, or at least you know how it's been collected.
Just while I'm having this thought, actually, if we were to build this thing the guy's talking about, and give that to the growers, then that could give them a map about their weed distribution too. So maybe that's something that a bit of a kickback.
So the incentive.
Yeah.
Mm-hmm. Yeah. Yeah, although I guess I was encouraged by the comments yesterday that from Greg, particularly that the growers would be quite keen to just collect this data from the fact that they can see the rate of potential.
Yeah, so maybe that gives them an immediate.
Yeah,
we've had something to put out there. I want to put it out there straight away. He's very keen.
Yeah.
From my conversations with farmers, they've been very enthusiastic about weed maps, even just simplistic binary ones. There's a weed here. Obviously, then you go to the next layer, which is adding on species mapping. So you've got then you've got like a multiple dimensional layer. You've got heliotrope, whatever on top of that. Those obviously are very powerful tools. Obviously, you need to get your mapping right. And you get your accuracy right, but even if you collected the data and then processed it with a slow but high accuracy model later, that can be very valuable to farmers at the end of the day to really get them on board.
So then out of that, we're trying to work out, I guess, develop this data collection standard or this report. Well, we've got the data collection reporting standard already, which is with AI. We just need protocols on either the hardware to collect the data, protocol on activity.
So have we got standards for resolution, height, lighting?
Well, it's in standards, like it's reporting standards.
Yeah.
But we need to
I think it might not be able to work out right now, but work out what resolutions or what types of cameras would be relevant to the topic.
I mean, my gut feel there is, at least for the medium term, those parameters are going to be dictated by tools that are commonly used. So I imagine a lot of those parameters will be derived, say, from the way foods operate. These are large capital investments. Developing something that operates outside of those parameters would not be immediately compatible.
Yeah. So can I also clarify something? Because there's two different regimes here which are going around in my head. There's one where the growers walk around with their mobile phone camera, which seems to me to be possibly a very small contribution, because they're only taking, unless they're spending all day walking around the field, they might take 200 photographs. And then there's a situation where we manufacture a unit, ship it out to them, they attach it to whatever hardware they're driving around, and we get zillions of pictures. So it's the one case which is very targeted. It's only a very few number of pictures, and then it's the other case where there's thousands and thousands of images. So are we addressing both of these situations simultaneously here, or?
Sort of, yeah.
I think they're totally different.
I think that's where the metadata is really important. To know what camera, I think you absolutely want to have as much data coming into the AI platform as you can.
Yeah.
Afterwards, because if we put too many restrictions on the sort of camera that someone uses, you're going to put coverage. And that in turn will just mean we don't get as much.
I think we're all talking about the supply of the standard piece of equipment, and of how they actually set it up and operate it, the data recording processes. So recording the metadata in standard format, camera operated in standard format, identifying what standard approaches are. Have we got a fair way down that track already? Being able to do that?
Standardized reporting.
Yeah.
Well, that's what we'd built on.
Yes.
And we're fairly, I think we're getting to the final stages of working out like angular field of view reporting for. Let me sort of work that out, but yeah, that's sort of very fine detail. But yeah, I guess the tool, you got the standard protocols perhaps collecting images with mobile phones. I feel like that's a resource that could be used. But then also the next step up would be investing in developing something actual hardware.
Yeah, I think the important part with the height is to be able to input that, because your height's going to change as you go through the season. So you'll start 50 centimetres off the ground and then you gradually get higher and higher above the weed. Weed's still down here, could be up at, could be a metre above the actual ground, 50 centimetres above the target. So,
yeah. And then of course, once canopy closed, that's it.
Yeah, and then your target becomes big. It's coming through your target. So,
yeah,
canopy.
So you need to sort of specify the minimum data requirement and build your tool based off that. If you're going to have
absolutely
to capture it.
So we're thinking about the end use. Working backwards.
Yep.
One thing that occurred to me is, I suppose a lot of the workshop has been centered around spraying and booms, which is great, but I suppose if you do move in the direction of having non-chemical application, things could get quite wildly different, I think.
Yeah.
Just in terms of perspectives, angles of view. Yeah, I just don't imagine lasers being 36 meters out on a long arm, that sort of thing.
Exciting.
Never say never.
Never say never.
It's just like, you just, a mirror, boom, there it goes.
Hundreds of lasers on the
No, you only need one.
Can use guy's sound effects.
You only need one laser.
So, all right, well, we want to try and keep moving. So, do we have some sort of agreement that the standardised approach that's delivered out from the researchers, I suppose, to the farming community is the best way, or do we have more of a random approach where we ask growers to just go out and take photos with the phone?
Like the former.
Standardised approach?
I think so too, because it sounds probably the closest to what people have applied to trying to actually implement these solutions. Like with Alex, you know, AutoWeed, they collect a bunch of images first. That's the first step, with a controlled way, so they can actually start training these models. I think that's probably the fastest way to get towards developing a solution that people can start seeing the effects of.
I mean, no, you go.
I was just going to say, in terms of basics, I mean, you get agreement from someone like you want to period, you've got all over the country, you've got multiple spray rigs. If you just went to them and said, right, here's a unit, it's cost $300, you stick one of those on each of your boot sprays. Straight away, you get exactly more information, and you've got a connection and a relationship. I think going to grow is still an element of variation of that different spraying techniques, different machines, and all those things. Whereas you get a lot of theory, they're going to be pretty well standardised because they're corporate. And diversity of area, ways like that.
And Garth, just something that Matt just mentioned about standardisation of platforms. You've got, so just the weed at blooming, you guys saw yesterday, Laura Curie's run 13 variations of that. It could give you an opportunity to set these specific heights that you want the photographs taken from. And all you really have to do is for consistency, say, look, we need this taken from the trailer wheel. The camera must be now 2 meters from it. And because you very, very little height change in that, because the booms are running on wheels. Everything else out there is running on hydraulics, suspension, cables, stuff that's moving all over the joint. And if I just follow up on Garth's idea of targeting, you've got Laura Curie, but if we went to Jason over here and said, hey, with your contacts, could you give us out of X regions 5 individual top farmers that you want to work with? There's some blokes out there that would just jump the opportunity to be involved. But if you produce, you go, because money's no object, Michael, obviously. You never is. You go out and buy a standard format camera that gives the high res, that exactly what guys are looking for. You send that kit, that protocol of how to do it very specifically. There's so many people that would just engage on this enthusiastically. You heard Trent from Laura Curie yesterday saying, hey, if you want to do something, and that I hear that stuff all the time. And you guys, with the contacts in the room here, we could find a number of people that would give you that standard format opportunity, across whatever geographical regions you want to take.
When I look at the unit you demonstrated yesterday, can you take that as shredded goals with platform? Okay, you might have to expand it, put 2 cameras in, so you get your 90 and 45, build the framework to, so for relatively low cost straight away, just giving it something, and then it's just becoming, giving it some the next piece of adaptation.
We don't want to record images of the weeds into text, so does find some great take a photo of that. Save the later, so it's
weed as well too, because you're already surveying all the volunteers, so whatever's left for your targeted weeds that you guys are focusing on. For us, it's flea bane, and everything else around it is bare. Essentially, it was 6 days after you're not there, and you come back and it's spots grey, so you've got clear images of the weeds you're targeting.
One thing to be careful about mounting on booms or those sort of things is that because they're fairly fast, 20 k's an hour, you do tend to end up with blur, or unless you have like a stroke or very fast shots.
Because that's not a problem. Seriously, you talk to some of these guys that are operating these machines in central Queensland and doing 13 kilometres an hour. But if you connect what the protocol says, we would like you to do 10 k's an hour. There is one day. There's a lot of really enthusiastic growers out there that would say, if that's the protocol, yeah, look, I'll run by this and do our 10 k's and whatever. I'm sure that you would find guys to do that quite easily. So I think you've got to get the parameters in your own mind, exactly what you need, and then the greater audience in the room here can find people who would assist them. John just walked back in the room. He jumped in. So you don't have to know what we've agreed to, just agree.
It's easy, right?
Thanks, John. Just saying the enthusiasm of people like Trent from companies like Laura Curie to actually support data collection we shouldn't underestimate how many of those trends are out there that would be really keen to support.
Well, the thing I'd add is just, it's not necessarily for, you mentioned me, it's not for me, it's for the industry, for a variety of different use cases. So we have to be, I guess, you could give a unit to different people, like different angles and whatever.
Right, so we've ticked off the easy one. Now we're going to move on to image annotation. Okay, so we need to come up with some sort of, again, standardised approaches, I suppose, and also try and figure out how we can get lots of images annotated quickly.
So I've got no reservations about saying that something like Mechanical Turk could work for broadleaf weeds, maybe not at the species level, but at least at the shape level.
Species specific process?
I mean, I think it could work when you have situations where the weed and the crop are distinct enough. Like say if you have a broadleaf in a grass, or grass in a broadleaf, something where there's contrast. And it might be clearer, but
you describe what Mechanical Turk is.
So sorry, Mechanical Turk, what it is, it's a product that Amazon provides for basically crowdsourcing out annotations. So basically, you can set up a task on there, and then there will be people around the world, usually in lower income areas, who will go on there and they will be paid a little bit of money to go through and annotate images. And so this is commonly used when you have a huge problem you want to solve, and it ends up being pretty efficient to use. It's obviously really great when you have something that's very easy to annotate, but as it becomes more difficult, you'll require more expert annotators. And I mean, they have all the systems they've built up there already supporting, like seeing how good somebody is at accomplishing these tasks and stuff. So that is an option, but it just requires money.
Yeah.
Okay, so simple scenarios.
Yeah.
Also, there's a comment that looks at it as well about other one. No, there's quite a few out there.
There's other options, yeah. That's just the most famous one.
Yeah.
Hi there, guys. This is Jeff Compson from GRDC. How you going?
Good. How are you?
G'day. Yeah, I'm good. Thanks. Yeah, I just put in a little comment there from. We've got another project under the machine learning portfolio, which was funding this database where there's image recognition taking place for crop monitoring. Also using machine learning, and they've just put in a recent milestone report. There's just a couple of services that were mentioned for data labeling that I've just put in the comment section.
Oh, that's right.
Yeah.
They even have prices there. If you guys have a sense of what's cheap and what's not.
I guess that sort of reflects what we were talking about earlier. A bounding box is exceedingly cheap just because it's so simple, but polygons, pixel-wise type annotation, I suppose.
Exorbitantly expensive, yeah. Just time consuming. Time's money, yeah.
Time's money.
Yeah.
So there's some good option there
on the previous slide, there was an item about synthetic images. Maybe that belongs on this slide.
Yeah.
So, I mean, I'd say those sort of services kind of answer a little bit of the second question. But when it comes to very hard to differentiate species or gnarly weeds like grasses.
So maybe our approach then is to start off simple and then just see how good these services are as we get progressively more complex.
When you say simple, you mean broadleaf or grass?
Yeah, something like that.
Yeah, broadleaf in grass.
Broadleaf in grass.
Yeah.
What was happening to Pierre that Greg didn't find grass to a priority one problem.
Yes.
Well, ryegrass.
Right.
Yeah. And so it'll be a growth stage thing as well. So seedlings will be difficult. So
yeah.
So big weeds and
that's another thing.
That's just because that's probably with validating groups and it's great for this part of the world.
Well, this is it.
I think there's differing views nationally in that regard. So.
I mean, this is one of the challenges. I think you do require tuning your approach to all these problems. I don't think the level solution will work.
no, that's right. Yeah. So I mean, so we are going to all crops, all weeds.
Yes.
Yeah, but we will, I think, come up with some sort of priority. So we'll start with the easy ones first to build momentum. Get everybody on board.
From my perspective, the current cost, what is the biggest where is the most money spent is on contrast.
Yeah.
So as a problem, it's up here. We'll get to see the challenge.
Yeah.
One other option for annotating is a community-based approach, so not to crowdsourcing, but to local areas or doing it in a free way. So there's first thing that comes to mind is something like Zoodiverse, where you can upload a series of images and you provide like a detailed protocol about how to label them, and then the just interested individuals, I guess, can then go and annotate those images for you. It'd be like citizen science.
Yeah, I think that was mentioned yesterday as well. Was something that would help make that a little bit easier for people to do is if there was some sort of app or something they could easily use on their phone or iPad. Just they're sitting on the can and they want to annotate 10 images. They can do it.
At the bus stop.
Well, you know what I mean. People will do it. It's like it's something you can do. Probably not when you're sitting up there in the tractor when you're supposed to be monitoring stuff, but
another option is like you said, you watch on Netflix.
Oh yeah. Yeah, well, there you go. It solves the problems with the weedits, with the people getting fatigued there.
It's until you run into something.
Oh,
yeah. That's right. Then there's a lot to do.
So how can you tell if an image has been annotated accurately? It's the right one.
Yeah, that's right. That's really good.
So what you can do is you assign it to multiple people. One of those people can be an expert or something, and then you look at the overlap of like the intersection over union. You're not on the model, you're actually doing the IOU of the person. And then if it's above a certain threshold, you accept it, or if it's not, so that's something community based.
That actually happens under the hood in some of those services that Jeff listed.
Yep.
So they'll farm out X number of images to each individual labeling, and there'll be overlap, and then they'll cross-check.
Yep. So you might, like I guess in effect, you might have to label each week 3 times to get the end result. Yeah, gotcha. Yep.
So is this done in stages? You have the bounding box, pixel level recognition, and then you have the species recognition. That's not all done by the same person, is it? This is each of different stages.
For 2 different concepts, I guess, so you got different types of annotation, but the different types of annotation can also be species level.
Okay.
So you have a bounding box that is just weed, a weed and a crop class, but you can also have bounding boxes for species classes and crop species classes.
Right.
You can also have segmentation with crop and weed species as well. You can also have image classifications. Okay. So there's 3 different granularities or specificities.
So there are sort of normally 3 different types.
Yeah.
So are we attempting to do all 3 simultaneously, or are we attempting to do all 3 sort of each in different stages?
It probably comes back to the type of weed. So with ryegrass, we've had issues putting bounding boxes around it because someone mentioned yesterday about how difficult it is to put like a box around a really small object. And it gets pretty vague. I've noticed Arnold, someone gets pretty vague about where to put the box. So that perhaps has multiple segmentation for ryegrass.
So, but in that context, it's not an option to go. You don't need to know where the tips are released. At all points, if you said the bounding box was had to be whatever size, so on a large tillet ryegrass, you just put that over the central growing point.
Yeah,
and don't worry about the rest of them. If you're going to hit it, I suppose then
We try to do that with our current ryegrass that actually presents that data. We try to, the idea was to revert the growing point, it's easier, but it's still a bit vague. So.
Yeah.
Remember, the footprint of the current application technique is going to be about half a metre. So unless you've got laser that's very, very close to being your preferred, then if you were leaving them to set expectations now, if you went over the centre of the ryegrass to a house point, you're going to spray in half a metre. It's, that's a 40-degree, quite a targeted nozzle four-spot spray. It's not a general purpose 110s everywhere. That's that's so
yeah. But what I was saying is even if you were targeting the growing point, it wasn't always accurate recognition of it. So it wouldn't necessarily take a look.
Oh,
yeah.
Yeah. Hey guys, I've got to head for an airport, so it was a pleasure. Thank you very much.
Thanks, Steve. Cheers.
I'll take if we can have any helps.
Yeah, sure.
Yeah. Cheers, Steve.
So I have got a bit of an idea for ryegrass based on the difficulty of your problem, the standard problem. So I was thinking that the people who most benefit from us being able to recognise ryegrass are the rural communities. So why not engage them on the lines of, okay, this is a massive challenge. Do you want to be involved in actually helping solve this challenge? Rural communities are always looking for money. There's always funding groups, school communities, school councils looking for extra dollars. They're the people who actually probably recognise ryegrass in the wheat. They know what it looks like, and they know potentially how to colour it in when it's present in the crop. So why not small levels of funding for these rural groups to help with the ryegrass recognition challenge? And then you can make it competitive. So
that would be a great story.
It's against the tomorrow
Steady.
You never know.
Yeah, I think coming into that, to get lots of people involved in application, there's definitely going to have to be some sort of education there.
Yeah.
There's going to have to be a tutorial somewhere showing people how to.
Oh, you'd have to do hands-on demonstrations.
So, I mean, Guy had to show me how to do this.
I think
fairly recently, and once you've done it a few times, you get the hang of it. But you do really need to be showing how to do it. Yeah.
Okay, so something like so that one I was talking about earlier, mechanical turk. If you want to go on there and you decide, hey, I want to annotate images, you have to go through like an annotation class. Basically, you have to go through this guided. It's kind of like a game almost. That's what makes it kind of engaging. Is they show you how to annotate it. So it starts off with something simple, like drawing around cats or something like that. So something like that, just I think probably make it a lot easier and a lot better entries. It's one thing to have like a guide or have to go there and have a class for it, but it's another thing to have something interactive person can go through and that also requires investment.
So doing both very early is not something to take to high school to some level of computer science, on agriculture or something. So it's setting up that we run a course, demonstrate, and then give 20 student.
Yeah. And you train them all at the end and they get a nice output.
Yeah.
It's one of those
Speeds
things.
Yeah.
And again, you could make it competitive between classes or schools and based on that accuracy of the model.
It is interesting. What's a teacher secondary school always how do we operate this in terms of engaging students that are relevant relative to the market?
We have 4 or 5 schools come out twice or 3 times a year, and always something for them to do. When they're coming out here, they come out on the 23rd, April or something like that, and just what can we do with those guys in an annotation class and take them out. Sadly, we've got a lot of but even doing that around different regions, I'm sure there's plenty of farmers and groups, other people who facilitate.
So I think to try and sum this up a little bit, there's going to be different approaches for different scenarios in terms of annotation of different weeds, different crop growth stages, and different crops. It's up to us to really come up with a bit of a stepwise process, I suppose, or structured process for the annotation tasks. So that's good. Excellent. We'll go on to the next one. Spelling error. Right, so okay. I just put this one up here. So we've got the Weed AI database. What do we need to build it other than just relying on our own inputs?
Our own being like the current research group or what we discussed.
So
Like
how do we get the industry engaged in using this database?
Publicity is going to be pretty important. Making people who'd be interested in using aware of being there and aware of, say, workshops, tutorials, interactive modules, teaching.
Yeah. Are other universities doing similar efforts, or would other universities also be interested?
Maybe yeah, probably. I know there's a Danish group who have similar ideas of building.
Maybe even in Australia, because it's very specific to Australia, at least at this level.
So we're the only ones, as far as I know, we're looking at image collections for growing crop systems.
Right, but other universities, agricultural departments and other universities might see what's happening here and say, okay, let's be involved. I don't actually have a feel for which other universities are.
I think very much secondary, but it's an issue with the ag degree. You get on to do, you're looking at something on engineering, whatever it is, about soil specifically, the process. At the same time, you take that next step into building the process.
My hunch is get big quick. I mean, standardize collection things on a rig, get it up onto the database, have publicity and awareness.
Yeah.
But I think also have a tolerance for, I imagine from a commercial point of view, people would be more willing to use the data than contribute to it.
Well, and that's,
which is part of the objective.
Oh yeah, absolutely. I think that's the whole line. Use the data.
For sure. But it just might mean we have to target a different set of people for contribution, like universities or research organizations.
So in that context, it's very important.
Yeah.
The response of the day is this obviously.
Yeah.
That's fine. What do you need?
Yeah.
So what do all the relevant players need, and then that feeds into your standardization approach.
Yeah.
Good point. I think we also need to record or run, as James said, workshops and start advertising it. A weekly 1 hour lunchtime workshop on using AI.
But the key vision is that next step into having engaged people. So not just the people who want to use it for that. It's how you make it so it's going to universities and other researchers make sure they're aware of broadening the
Weed Smart's a cracker because Weed Smart's got everyone that's interested in weeds watching these webinars. So if it was they'll do a ryegrass webinar at the end of it, you get a 5-minute spiel on, hey, we're building this platform. Would you guys be interested? Sign up for a workshop or something like that. Just a bit of promotion through the existing channels that are working really well in weeds.
do a podcast, do a webinar. Might die on parents' status situation.
So we do a comment from Andrew. I'd be keen for UWA to be proactively involved and also help with WA engagement with schools.
Thank you, Andrew.
And James, because people change
everything, I think we have to keep going back to what the big benefits of Weed AI are going to be for the industry. And the fact that it's an open platform is probably the biggest one. It's going to bring everyone, regardless of what Bilberry and the commercial players do with that data. Brings everyone up to a level playing field at the start, and then we
Yeah, it's going to make it a lot easier for people like Alex, starting out something small from get-go. They can go and they can get images, and then they can start testing things out. Or even if Bilberry wants to test a new scenario, they can start working with our images instead. But yeah, these on there.
Yeah, so are we ready to wrap this up?
Sure. If you want.
I think we've made some really good progress.
So what we believe, that slide is probably the root smart piece too, is the representation of groups, great researchers, ourselves, who also play a part in this process in terms of weed control, and that's the big regs, but also the commercial regs as well. So how do we find what's in rec, nutrient owners, etc., and dragging them into this aspect as well.
So so I just wanted to put up this little graphic to indicate that it's not just researchers heading off, or herbicide companies or weed control companies heading off doing all this good work. We have to do it interactively, collaboratively, to make sure that we all are on the same path and not heading out in all sorts of different directions. I had hoped that we'd get a few more growers engaged, but it's always challenging at the busy times of the year. But I think we had the opportunity but we need to keep that engagement going and make sure that we do with the ongoing interaction. All right.
So what's putting from public comment release statement in terms of you release something, is there any ability at all? Again, various places to leverage that.
Yeah.
What we're doing.
So there is a ground cover article in the works. Something at the start. I guess we've still got some work to do to make the AI a lot more appealing, I suppose, and much more.
It's part of the journey, making sure people are aware of the right. So, GRDC funding a project that's focused on this. Yes, the ground cover will do a great job of that, but there are other platforms outside of ground cover. I mean, from a commercial perspective, you've got something now. Start talking about it, and every time you add something, it gives you another opportunity to enter the market. And so, we've added this. I think with our so there's no point waiting for it to completely done. And here it is. Start talking about it now. As broad as possible. It's relevant.
Yeah. No, that's exactly right.
Your microphone working, guy? I can bring mine over.
Yeah.
Right. There we go. Okay, so this is the, would have seen yesterday, Henry do a great demonstration of it. But basically, this is the homepage when you go to Wood AI.
you'll come up with this. And so yesterday we were at the farm, I think it was in Junee. We ended up took some photos there and also in Alterratech just with my phone. So the idea was to hold the phone out at just a shoulder height, which is about 1.5 meters, take photos so you can't see your boots. And then following that, you can then upload or annotated it, such this morning while we're talking, annotated 10 images with heliotrope, I think a bit of annual ryegrass and the Indian hedge mustard, I think it was there, and also some south thistle. And the process after that was to go to the editor. So at the top here, if you go to editor, you can sort out the growth stages and the crop type. So this one, it's a fallow. So there was, I think that's been just updated because of what I did this morning, but you select fallow from the list. Then the growth stage will then be NA because it's just in a fallow field. Then for the soil color, it was a red-brown soil. So it's like that. Surface coverage, it was a cereal. So it was basically 100% coverage, but underneath there was some red soil. So you select cereal, the coverage was huge, 75 to 100. And then the location, I just put it as I'm left in town. I didn't want to put the farm down there. That you can get from Google Maps. So if you go to Maps, then say, or you could go to Wagga, drop a pin. So I'm not familiar with this. And then you can copy the depths down there. That's the longitude and latitude. So if you ever want to get longitude and latitude to enter in, you just go to Google Maps. Just use satellite to get to where you are or something. Hit your phone, do it that way. Copy that in. So now, and once you've copied that in there, then you can move on to the photography. So obviously I haven't filled out completely. And so to work out the camera make and camera lens, the easiest way to do that is if you go to your actual data on the phone. So I'll just reshare to that. Actually, I'll need to share my screen. And so if you right click on an image, it will show you all the metadata for the photo you've taken. You do have to be careful as well to make sure you've deleted any location data that's on the phone too. So you don't have your, unless you want it there, but that does, some phones do have location. Or is that screen?
It's stripped out.
It is stripped out. All right, that's fine. Then. Okay, cool.
It's important.
As it's stripped out, it's stripped out as part of the.
Yeah, you want people to actively put their location. You don't want to accidentally.
Oh, so anonymous.
But isn't the, I mean, the location's part of the point.
But that's the field.
It's a point that's given for it, rather than like, so with a cell phone camera, whenever you take a picture, it's going to say the specific location. And so for now, we've stripped out that information just to protect any trade secrets or anything like that, just in case someone's sensitive about someone knowing exactly where this ryegrass is on their phone.
Yeah. It's more so you can actively, you might come back later and actively put it up there. But it's just so.
If you're able to strip that data from the information that comes from the image, could you get it to automatically take out the camera model and resolutions and stuff?
Yeah.
So it's not what I can't do. It's just I'm going, oh, there's a whole lot of back and forth here. I want to be able to, I can upload a photo.
Yep.
It needs to run through something and strip whatever information it can out and fill it out the best it can. You know, I understand the order of the security, but you know, I've got to find basic models. You're not going to do it for one photo.
I don't say the only for this once. So it's
Right,
you have
okay,
to
so
set a photo.
per
This is all per data information. You got 1,000 images like this, and you do exactly the same process. But yeah, for the moment, if you, so this has your focal length, things like your camera model and camera make. So then you can just copy them into here. Then you do camera height. So it was 1,500 mils above the ground. Camera angle.
There's an issue with
Yeah.
Camera angle is 90 degrees, and then you do things like field of view on the ground.
which is the angular field of view of the camera, which I think will, in future versions, will calculate for you. Then things like ground speeds, lighting with natural, and then a short description. So this can be, I think it was afternoon. So collection of photos from phone in the afternoon, clear day, etc., etc. Then other details are just weather description, so clear, full sun. So once done add context, you can download that. So I've already done that. And you can go to the metadata editor, and you just enter the dataset name, the description. You can copy in the license, so it's currently the 60 by 4.0, and then the date published is just today's date. If you have previously published this work, that's against that date too. And then the other options here are things like adding, if you already have a DOI, so it's being referenced or published already, you can add that, and also a funding agency as well. So that's all the metadata done. And then once you do that, because I labeled it in a different format, I have to convert it. But if you did label it in a COCO format, then you wouldn't have to. But you still have to use the importer. So I'll say I've labeled it, it's been converted, and I'll remove this. Then if we go back to the home, upload, I can go to where I've saved all these files, then start the upload process by selecting Weed Cocoa, begin upload. And then you just drag and drop it in. So there's the Weed Cocoa that I've converted. Go next, you select all your images, they'll upload. You wait for them to appear, and you're done. Already done that. So then if we go to data sets or go to explore, I know that I labeled a bit of heliotrope, so I can select that, and then these are the images yesterday. So that have appeared, but they'll also just appear if you scroll.
You drew the box.
That was me. So you can see them appear in the main feed as well. The other interesting thing you can do is if you search up Ardlethan, and then you go down to 10 kilometers, that's all the images I've taken. Okay.
Exactly, yeah. Yeah. Just lowering the barrier of entry, making it so it's easy to just drag and drop. As few clicks possible, as straight as possible.
And is it possible to embed the annotation software within Weed? So we can just.
Okay. Well,
I mean, like question.
Well, so I mean, the app.
Yeah.
Talked about is take the image.
Yeah.
Like that across it.
So I think of a weird data, pretty complicated. You just give consent if you want the location to automatically go.
Yes.
So, but I mean, this we're talking in probably 3 or 4 years' time. That's going to be met.
Yeah.
The first instance, you're going to go across the wheat belt, collect massive images, standardized.
Yeah. So yeah, like something like an app that would be user friendly, that would be excellent. But it also just requires.
Yeah.
It's just development.
I mean, also at the moment, you said throughout the past couple of days, it's the data collection, assuming we get a standardized method, get that out there, we'll be swimming in data.
Yeah.
It can be, I mean, surely it's better to keep that data and have it unannotated until we get the annotation sorted. So is there a way to upload unannotated data to this?
Not at the present, but that's something that we could talk about.
I think you need to keep databases and data anyway. So
What we're talking about money, if we're going to be collecting fast finds and data to store it on this, where physically will that put that?
At the moment, it's stored on University of Sydney allocated storage.
So who owns that?
The University of Sydney is Well, it's somewhere being stored somewhere in New South Wales on servers that the University of Sydney sources.
I can't imagine that the quantity of data that you would expect to be very huge. But that's a different calculation. Yeah.
So currently that's stored in the university's existing infrastructure for storing research data.
Because if you know if a few terabytes come in, it's shocking. It has to be kept and maintained by someone.
This is all stored on cloud storage system.
So you can get an app, it's not just the document, the app, the name, the app, website, everything, you know, it's paying for this.
Customer support.
Yeah, the thing is also that there's a good question is that the idea of containing support is something to consider. So you can't just make it and just leave it there. It needs to have. Yeah.
Start telling you. That's right.
Well, I guess the idea is that, like, I did this while everyone was speaking this morning. I labeled the images and uploaded them, and I know I've done it a few times, had some issues, but it's if someone is committed to doing it, it is possible that, as it currently stands, to do it fairly quickly. It's just that it will take half a point. So there is a barrier to entry at the moment. It's probably uncomfortably high if we want to get large scale adoption. But if there are select groups of people who want to take on this, who are slightly more early adopters and more keen to do it,